you go. We're all set.
All right. Well, good morning, everybody. Hang on. Let me just flip my screens so I'm looking at you. Um, so good morning, and thanks for being here. Thanks for continuing on with the program. I think it's really beneficial to the organization, and we appreciate you all putting in the time. Today we're going to talk a little bit about strategic capital planning, and I think you'll find that there is some fact-based science behind capital planning, and then a lot of it's an art of balancing you know, when you can very easily quantify the age of a piece of equipment, how well it functions, those factors, but then what is an impact downstream, right? Are there pumps, are there VAV boxes, are there, are there conductors, whatever it is, right? Um, that need to be part of that project, right? And then how do you layer what you know you need to do into the available funding. And then how do you layer that into known projects that are going to happen in a facility moving forward? And how do you make it all happen? And at the end of the day, I think you try to make it as good as you can, and you just have to go with the best. It's never going to be perfect, right? And you kind of have to go with what's the best solution with the information you have. So, like all these, we're going to start with our cause. Um, and really, capital planning is how we're able to continue to create healthier futures and bring remarkable experiences to life, right? If our facilities don't function, um, really um, can't take care of our patients, right? And it's really, I think, when you look at the key drivers here, we really like the discovery is a huge part of capital planning, right? If we don't know our buildings and the condition they're in and how they function, um, it's really hard to plan for capital, right? And it's impossible for any one person to know everything about every system in every building. So it's really incumbent upon leaders to gain information from their teams, right? So we're empowering our teams with their knowledge to gain the information they have as we're trying to discover what opportunities there are for capital improvement. And then lastly, I would just say, it's all got to be done together, right? So um, it's easy for me to put a list of capital together and say, hey, we need $100 million to put back in these facilities. And just say, like, take it or leave it, right? I need $100 million or the buildings are going to fall down and we can't function. But you have the medical group saying we need $100 million to build new clinics, and you have imaging saying we need $100 million to replace imaging equipment, and you have the OR saying we need $100 million for robots and robots and cameras and whatever else, right? So we have people saying, hey, we need to build new hospitals that are $400 million, right? So there's always competing priorities. So what you really have to, the together piece is really working together with all the folks who are requesting capital in a given time and really getting to the underlying, like, hey, these are the must-haves, and finding ways to as a team, as an overall Novant team, implement the capital the best way possible. So I think you guys know the housekeeping rules. Let's keep our cameras on, participate in the group activities. If you got to get a call or step away, just mute yourself. Um, you know, um, if you want to stop me from talking and say something, raising your virtual hand's a good idea. Wave your hand, yell, speak up. Like I think both Jeff and I, want to keep this, particularly on the virtual calls, try to keep it as engaging as possible. So if there's something you want to talk about in the moment, just stop us and we'll talk about it. Um, and then there is going to be some diversity of thought in all this, right? So let's make sure we have a good debate, and as usual, we'll take some breaks about every hour. So thinking about capital and operating expenses, um, give me some ideas of what you think what a capital expense is and what an operating expense is and what's different between those two. Oh, go ahead, Joe.
To me, I believe capital is probably a little more long-term, um, somewhat futuristic, to a point. And then the operating is obviously now in the present that you're having to deal with
Yep.
before the future.
Anybody else? So kind of think about, one way I like to think about it is in terms of your car, right? Or your truck. Like the actual car or the truck is capital. Um, but when you buy tires, brakes, those are all operating expenses, right? Gasoline, all operating expenses to keep your vehicle running. So, think about it on some of the pieces of equipment y'all deal with, right? Or um, you know, some of the facilities we build, right? So, air handler, generator, what are some of the things that you think that would be capital versus operating expenses with specific pieces of equipment?
Luke, did you have something to add?
Oh, sorry.
No, Joe hit everything there, but now I got to think about this. So give me a second.
Okay.
Will?
So, I mean, maintenance and minor repairs. So, like servicing pumps, changing filters on an air handler, as an example, all operating expenses. But if you had, um, wanting to upgrade to VFD or something to that effect, that could qualify as capital. Sometimes it's cost, and then obviously if you're extending functional life expectancy of the device, you can capitalize that as well.
Great. Other thoughts? So, generally speaking, the way Novant has capitalized or defined capital, it's got to be something over $5,000, and it has to extend the useful life of the piece of equipment, right? So, um, if you use an air handler, for example, right, and again, part of this is a little bit of an accounting. Um, it's really all accounting based, and sometimes doesn't make sense, and you just kind of have to roll with how it goes, right? But so like let's just take an air handler for instance, right? Like we all know if we replace an air handler, the actual air handler itself, that's a capital expense. Um, if you were going to replace the motor, the fan motor in an air handler, that's an operating expense. But if you were going to take the fan out, the motor out, and put new fan wall in there and put new coils in there, right? You're extending the life of that asset. So that would qualify potentially as capital. On the electrical side, we got some of these huge breakers that are, 30, 50,000 bucks, right? Just because they're 50,000 bucks doesn't make them capital, right? And in like on a switchboard, unless you're replacing like the entire switchboard, just replacing that breaker doesn't necessarily make it capital. So it's one of those things where there's some easy ones, right? Like if you're replacing a generator, it's capital. If you're changing the oil on the generator, it's operating expense. If you're replacing a radiator on a generator, they're probably going to go operating expense, but you could make the argument that you are extending the life of that piece of equipment, right? So it's a little bit of it's not always cut and dry. But just think about the way I like to describe it, and is just think about it from like your everyday vehicle, right? Like when you buy a vehicle, that's a capital purchase. And then when you got to do tires, brakes, wipers, all that fun stuff, right? That's all operating expense for you to maintain that and keep that piece of equipment operational. Any questions about any of that? I know it can be a little confusing, and it's not just a cut and dry answer all the time, particularly when you get into the nuts and bolts of particular pieces of equipment. So, if as you're thinking, as you hear things through the day, and you may have some questions you want to discuss about that more, don't be afraid to stop us.
Guys, I apologize. I rebooted and my camera still isn't working, so I'll work on it at the first break. I'm gonna try something different, but for now, I'm gonna have to roll the way we got it here. But Joe, you hit it on the head, man. You really, exactly like you said, we, at our hospitals, we have two different ways. We have our operating and our capital, which we've already discussed, and you mentioned that operating is for all those day-to-day things. It's just a cost, is to keep it running day-to-day, things like utility bills. I mean, in the hospital, we're talking gas and water, electricity and all that. And Will, I know you mentioned those routine repairs. Those are all part of it. Even supplies. I mean, I guess in my old day being in plant engineering, we had a stock room and it had all kinds of things, from nuts, bolts, light bulbs. I mean, all that stuff would still be, I guess, would be on your operating. But then your capital expenses are for those big pieces of equipment. Anything that's going to last over several years. And then you get into the depreciation, which is more of an accounting. I don't know if I'd call it, if it's a law, I guess it would be accounting laws. What the IRS, how they allow you to do it, capitalize and depreciate it. So, and that's it, pretty much year to year or long-term investments. And then the big difference is just how big the purchase is and how long it lasts. If it's a cheap item, then something that you use up fast, then that is typically an operating expense. And the whole cost of that hits your budget right away, just like Matt was talking about a truck. You go fill up your gas tank, it hits out of this week's paycheck instead of what you save for the month or you make that next car payment. So I think of it that way. I had never really thought about what Matt mentioned that. That's a good analogy of the vehicle. Where the capital is it's a bigger purchase, like buying the cost of that truck and financed it over 6 years or whatever. And then it's a capital asset and you're continuously paying on it month after month. And you know what that cost is going to be, and you spread it out over that 6 years. I think that pretty much covers it.
Yeah. So why is capital planning important, right? From a leadership perspective, so if you go back, a decade and a half ago, Novant did not have a dedicated facilities infrastructure dollar amount in our capital planning. So when Novant does capital planning, right? Novant this year is working on capital planning this year, right? Novant will be like 12 billion in revenue, right? We want to run at a 9% operating cash flow. So that gives us like $1 billion of money left, right? We have to pay debt, which is about 250 million. So that leaves about 750 million to cover all the capital, right? And that capital is broken up into there's an infrastructure, facility infrastructure bucket, there's an IT infrastructure bucket, there's medical equipment replacement bucket, there's an imaging replacement bucket, there's a contingency, and then there's like the growth projects, right? So Scotts Hill is wrapping up, but Scotts Hill would be one of those. Anywhere we're going to build a new large facility, the bed tower expansion at New Hanover, that all comes out of that capital bucket, right? And as you can imagine, there's more dollars, right, that people want than that bucket allows. So it's really important, right? So 10 years ago, we didn't have dedicated funds to replace infrastructure. So, and the reason we didn't have it is because we didn't do a really good job explaining the need, right? So why it's important, right, is really, and why from a leadership standpoint, it's really important to know what you need and what the building is you have to be very able to clearly create a business case for, and it seems counterintuitive, right? Like for all of us, like if the generator, transfer switches, air handler, chiller, whatever it is, right? If they don't function, the facility doesn't operate. But from people who don't do that every day, that, you know, they just think we do a lot of magic and wizardry and the stuff works, right? So when you say, hey, I need to replace this chiller that has no net new patients, no additional revenue, or I can go do this, whatever, 256 slice CT where I can see these patients and do this higher level of care, right? When you compete in those two markets, you got to be able to really say why the chiller is important, right? But the very first step of that is knowing what you need in your facility and being able to be very transparent and honest about the condition of things, right? So, you know, you really just need to understand. That's the first step, is just understanding what the needs are. Go ahead, Joe.
Just a quick question, kind of aside, you know, not knowing, how much effect decision wise, like say for capital budget, is the board influence for our capital spending over our hospital folks like you?
Yeah. So, what happens every year is there's a proposed capital budget. So, you know, they'll go to the board and say, hey, here's how we're going to allocate capital this year, right? Here are the kind of routine pieces, you know, routine, like I said, like medical equipment, infrastructure, here's all that. And then here's the projects we intend, like the big construction projects we intend to bring forward. And that's kind of as like a generic plan, like, hey, here's what we think we're going to do. And then any project that exceeds $50 million requires board approval at Novant Health. So once an individual project reaches the $50 million level, you have to get board approval. So my point in kind of going through some of that history is like, it's really important for you to know the condition of your facilities, because these are where we're planning long-term investments, and particularly when you're in facilities where we're planning expansions or upgrades, right? It's just like, hey, I got to replace this air handler, but we're also going to put an addition on that space. You know, do we combine the air handler replacement and the addition to make sure we get one new piece of equipment for both, or how do we do all that? Because, you know, this all, like, it requires a lot of planning and coordination, and it's never perfect, right? Because like I sit here and you know, Joe and Alec know this, like I sit here and look at this old bed tower from the orthopedic hospital. Like that was supposed to have been demolished as part of the project when we built the new orthopedic hospital, right? And, you know, Novant and healthcare in general were really bad about demolishing things that we're supposed to demolish, right? So, you know, a great example in the coastal market is we were building Scotts Hill, we were going to move out of the orthopedic hospital, but lo and behold, we're staying in the orthopedic hospital, right? And that's what creates the capital planning challenges, right? Because at the orthopedic hospital here in Charlotte, at the orthopedic hospital in Wilmington, we had been saying like, hey, we'll keep this stuff running, we'll band-aid it, we'll make it work because we're going to get out, and then we never get out, right? So that really messes your capital planning up, right? Because you're kind of, it's like, you know, with Jeff, like Medical Park was that way for a long time. And then we finally invested some more money in Medical Park to get it back up to speed. So, you know, there's facility, there's a lot of parts to the puzzle that go into capital planning, and it's never perfect, but knowing exactly what you need and being able to tell people why you need it is really important. And again, it comes back to, right, like we can't take care of our patients if we don't spend capital, right? So, you know, you'll hear a lot about, one of the things I think that frustrates a lot of team members is, you know, we're making money, right? But we got to save money, right? And we talk about making these big dollars, like, hey, we'll have $1 billion, and we'll have $750 million to spend, right? But that $750 million is not a lot of money once you start taking in, you know, but between IT, infrastructure, you know, replacing medical, just to keep the business running is probably about 350 or 400 million of that 750, right? And then you want to grow and do new things and build new towers and replace towers. And, you know, so one of the things that's challenging, right, is we need capital to take care of people, but that means we need to be diligent in our operations, so we have the capital to reinvest in the business.
A lot of
Because-
things competing for that money and the business plans to support it are key, to show what either needs replacement or showing if you do something new, what kind of return that may bring or how it's gonna be beneficial.
So again, we need to make these investments to keep the building running so we can see patients and get paid for the services we're providing. So from a purely plant engineering standpoint, we play a really key role, right? Because we can identify those equipment needs. We're providing the cost estimates, really evaluating equipment life cycles, right? Like we know that certain pieces of equipment last longer than others based on location, where they're set in the building, whatever it is. Certain pieces of equipment are, will have a better lifespan. And then, it really helps us make sure that when we come up with new projects, they're feasible. And one thing we need to look at it, right, is like, as I talked about earlier, you have a new revenue generating project that, is going against a chiller replacement. It's like, okay, yes, the chiller replacement doesn't generate revenue, but what it does is it protects revenue, right? It allows us to have our ORs open. It allows us to have our imaging equipment running. It allows us to have patients in rooms. And you, without that, you can't do anything, right? So it's the basic bones of the work. And I will tell you that, a lot of the work around what plant engineering does and how we're able to get the funding we need is really built on the trust of, there are, outside of our group, there are very few people who actually understand what we do and how the equipment works, right? So our ability to get funding is built on a high level of trust that we are allocating the dollars to the right place and we are minimizing, we are maximizing the ability for our buildings to operate, right? We're putting the dollars into projects that are going to keep our buildings functioning for our team members and our patients, right? So it's really important, right, that as we continue to work on capital, we're asking for those must-have projects, right, that keep the building running and keep patients, keep our ability to see patients and keep them safe and keep our team members safe.
Yep. Okay. So when a hospital has a considering a capital project, it's really important to you guys start off by just identifying who the stakeholders are, which are the people going to be involved with it, have a stake in it, or people like you guys, or most of you guys who are plant engineering, y'all going to be responsible for maintaining it later, or so you're impacted in some way with the outcome. There are 5 main types, and I know there's 6 listed here, but the 5 is the project owner, and that's typically a department leader who submits the project request or gets the project going and oversees the completed project. Then number 2 is administrative owner. They typically is a supervisor who decides whether they're going to fund this project and where it's going to come from. Project support team, it's key departments that contribute to success. For us, I think about the construction projects. I mean, every project, we've got a construction project manager, we've got an IT project manager, we've got someone typically from plant engineering, if it's a expansion that's involved and works with us, if it's a net new hospital. I mean, all these people involved here list out infection prevention, security, we've got it in every facility. So all those people are involved. Then you got the operational owner, which is the person or group that will directly use the equipment. So you take like an imaging, a new CT room or imaging suite, whatever it may be, MRI. I mean, you've got your people there who will be using it. So that's your operational owner, or it could be nursing staff. And then you got your maintenance owner, which a lot of you guys are responsible for keeping that stuff up, keeping the equipment running. Also would be people like biomed, for some of those medical equipments, or I guess in our case, TriMedics, which our outsourced biomed. And then in some cases, you'll have those others that's listed as also involved. It might be people who are consultants or advisors. Sometimes we've hired outside consultants. Sometimes it's internal people like our physicians and surgeons that just provide input to the projects.
So the capital equipment planning process. So, really making sure we make informed decisions about where we're investing. And, this highlighted area here, it's not just about what's broken. So I regularly use the example of like an air handler, right? If you have an air handler in your building that needs to be replaced, and you're like, hey, that air handler needs to be replaced, and you're not looking at the downstream equipment, right? Ductwork, VAV boxes, controls, dampers, right? Are you really is replacing the air handler really a good investment, right? So a couple of true stories at Novant Health. We replaced an air handler at a facility and just did air handler replacement, right? And it was a facility where we were having, patient complaints about temperature control in the rooms. Replaced the air handler, didn't help anything at all, right? Why? Because the terminal boxes still didn't work, the controls still didn't work, right? So you have to be mindful when you're thinking about a capital project, like what else do I need to do when I do this whole project, right? Because ductwork in and of itself may not be a capital expense, right? But when you're doing it as part of a project, you can replace that. Now, challenge we all have, right, is how do you keep the spaces that are occupied open while you do that? So makes it much more challenging, right? Other real life example is, replace that air handler serving an OR or ORs, and we didn't do anything to clean the ductwork. And we started, we had higher static pressure in the duct, and we just started blowing junk into the ORs, right? Not a really good situation, but, maybe I don't need to replace the ductwork, but maybe I need to make sure I clean it, right? Maybe I need to make sure we do all the downstream stuff to make sure that the system functions properly. How we do it. So obviously we have the CMMS with Brightly. That is tied to another module in Brightly called Origin, which is a capital planning tool. And Origin ranks the equipment by age and risk. So every year we run a report out of Origin for each facility of like, hey, these are the assets based on age and risk that should be replaced. And then we insert a human element into the conversation where that list is then shared with the facility managers, or we ask the facility managers for a list of their projects and we try to marry up the lists, right? Because one of the things we found several years ago was when we just asked people for a list without comparing it to our inventory data, was the request was always for equipment that created a problem, right? So we did a ton of HVAC work primarily, but we missed things like elevators and roofs, right? And electrical gear, right? So that stuff functioned, right? And it wasn't a big problem. So we got to a point where we were replacing HVAC equipment that was nice to replace, but we were missing roofs and elevators and some of the other equipment that was necessary. So it's really important to kind of have a dual approach, in my opinion, where you have your inventory list, and you have that ranking based on risk and age, and you compare that to what's really happening in a facility, right? Another example, right? So Kernersville and Brunswick, when they were built, had the exact same water-cooled chillers from York put in them, installed in them. 10 years in, we had replaced both chillers at Brunswick because they never worked right from day one. Those same make, model, number, like literally within like 10 digits of each other's serial number chillers function perfectly fine at Kernersville, right? So like that's where like those at Brunswick, those chillers would have never showed up on a list. They're water-cooled chillers, right? They have a 25 to 30-year life cycle. So they're showing to be replaced way out, but we were having so many problems with them, and that's one of the things that we've been working with Brightly and on is why we really push to the technicians and all y'all about making sure when you do a work order that an asset's associated with it, because we can take the asset maintenance data from the Works Hub Brightly product and layer it into Origin. So if you had two chillers, right? Just let's say there are two chillers installed at the same time. I can actually use the CMMS data to say, oh, well, chiller one had, Joe had to work on chiller one 10 more times than he had to work on chiller two. Maybe we need to look into chiller one a little bit more. Maybe that needs to be replaced before chiller two, right? So that's part of what we can do. We just got to continue to work that. But again, we just have to make sure they're standardized and updated regularly, and it just helps us prioritize funding across the system. So evaluating condition, like we said, operational cost, how much is it costing us to keep this up and running? What's the uptime? How often are we having to replace this equipment? How often, what are we doing to make that work? Like our reimbursement, like how do we get paid, right? Does this serve the ED? Does it serve imaging, or does it serve administration, right? Or does it serve supply chain, or does it serve a non-clinical a non-revenue generating department, a non-patient facing department? Lost revenue, right? So, we do a lot of work. We've spent a lot of time and effort making sure ORs are available, right? We've spent a lot of time and effort making sure buildings can run on emergency power. And I would say the emergency power is probably less about loss of revenue than more about patient safety and team member safety, but making sure that we can work from that. I think another place where we see, what we're learning is mission critical is all of our IT systems, right? So if IT systems go down, we don't really function well anymore. Another thing is availability of parts, right? These equipment manufacturers are changing equipment so fast. It seemed like for a long time stuff was available for 10 years. Now it's like, hey, we have a new product. We discontinued it after 3 years. Parts aren't going to be available in 2 years. Good luck, right? So that's another place. And then, like we were going back to the mission critical, cybersecurity is important, right? So all this equipment anymore has a data port on it, and people can pull data off of it. And more importantly, they can get onto our network. So that's why there's a lot of work that goes into how this equipment gets tied into the Novant IT network over time. And a good example of that cybersecurity piece is Swisslog. So the pneumatic tube system, we've slowly been going to a web-based, but a centralized server, centralized server for Swisslog so that it's controlled and IT can secure it and do a lot, because before that everything ran on like individual PCs at every facility, right? And it was not easy to take care of from a cyber perspective. Equipment usage. So again, how is it being utilized? Is it functioning at 100%? Like, are we able to get what we need out of it? This is more, I think you're going to see this more on like the medical equipment side, right? You got a piece of equipment that you use once or twice a year for 1 or 2 patients versus something that gets used every day, and gets used regularly all the time. So a couple of key questions when we're evaluating equipment usage. What happens if it breaks? Like if this piece of equipment fails, what happens? Does it talk to some other system, building automation or the electronic medical record? Is it something, that's compatible with other technology we're already using? What does it cost for us to maintain? Does it generate revenue? And could a new piece of equipment replace or improve performance? So, asset interoperability, right? Really crucial. ICU monitors, right? We use, or even and I want to say even like cardiology monitors, right? Like it seems like we monitor more and more patients, right? But if we're using GE in a facility, you're not just going to layer in, well, we have over time, right? But ideally you don't want to, if you're using GE monitors, you don't want to go layer in a Philips monitor, right? And add a whole other layer of complexity. And then on our side, equipment like chillers and cooling towers, how are they talking to our tritium system? And how are we operating them effectively? And if equipment can't communicate with other systems, it's going to kind of hold us back, right? So I know the pace of technology change can be overwhelming at times. But I think we're all, it's headed that way, right? And now we got to figure out, how do we leverage the technology to make our lives easier? How do we take the data we can get out of these systems, and instead of it just being more data points, how can we use, tools like, predictive analytics and AI to turn it into actionable items, so that we're not just looking at a bunch of data points and trying to figure it out, but it's helping us pinpoint what we need to do. All right. So true equipment lifespan and depreciation is just another place, to help um, categorize, rank projects, right? So, reviewing maintenance logs and records, right? How often the equipment's been used, whether or not it's been maintained. Most equipment anymore, right, is like bigger equipment. You can get a lot of data off of that piece of equipment about how it's functioned, what the trends look like. And it gives you a lot better picture, right, of what's really happening. If you look at, life expectancy of different pieces of equipment, we run most pieces of equipment longer than the manufacturer's life expectancy, right? But what's the purpose, right? If we can get parts, if it's working properly, if it's doing its job, does it need to be replaced? So there is the Hospital Association does have a guide that has the estimated useful lives of depreciable hospital assets, and that's really helpful for finance teams and our facilities teams to understand how long that'll work. So without getting into a lot of detail about depreciation, right? So when we buy a piece of capital equipment, so say it's $1 million, we paid $1 million for it, right? But instead of on the financials, like let's just say it's Brunswick Medical Center paying $1 million in that month for that chiller, instead of that, they start getting a depreciation charge. So they take that $1 million, and let's just say it's 10 months, right? Like, so that chiller depreciates in 10 months, which is much longer than that. It's probably like 20 years, but let's just say it's 10 months because I can't do hard math. So $1 million chiller, 10 months. So instead of you paying $1 million in February for that chiller, you're paying $100,000 for it every month. So, you take that same $1 million chiller and take that number and divide it by, 20 years, that monthly charge for that chiller gets way smaller, right? So that's why we capitalize assets, because if we were using an expense to expense that asset, we'd have to account for every one of those dollars that the day we paid for it. But since we're buying a capital asset, yes, the cash goes out the door to the vendor, but from a financial accounting perspective, we're depreciating that asset over time. The other reason depreciation is important is because of the way you're technically paying for it, right? If an asset hasn't fully depreciated and you need to replace it, you either need to replace it with an operational dollars, which is that one-time cost, or you need to pay off the rest of the depreciation before you can replace it. So you'll often hear people ask about things like that, right? So in the term people use is book value. So if a piece of equipment still has book value and you want to replace it, you either have to write off the rest of the book value and you can use capital, or you just have to use operational dollars. So that's why depreciation is important, is because, and you'll often get, like when we do construction projects, we'll try to break down the capital allocation numbers like to as many pieces as possible, because they'll depreciate the whole project over time, right? So it's important when you go to renovate and all those things. Like if that project hasn't been depreciated, you can't use capital dollars to replace it.
Yeah, they'll even get into looking at, like if it's from a renovation, they'll even look at, say, the flooring is wearing maybe in a spot that gets heavy traffic, but they may say, well, hey, this flooring is only 3 years old. And the lifetime of carpet should be 7 years. So they sometimes have to expense it instead of, they can't capitalize it to replace it.
Will?
Yeah, so is there a view in Strata that shows you what is still depreciating? Or how do we track that for assets?
So I just asked Melinda Gallup and the fixed assets team.
Fair play.
Because you don't know. So the challenge can be the way fixed assets depreciated a project. So for instance, like the Brunswick example I used, one of the problems or one of the challenges we had when we had to replace those chillers was they put the entire energy plant of that hospital on the balance sheet as one depreciable asset. Right. So it was like 25 or $30 million that had to depreciate over the 20 years. So like there was no way, like we couldn't even write off the exit. We just had to expense it. Right. So I would say, reach out to Melinda Gallup and the fixed assets team and they can give you that information.
Yeah, I mean, that's kind of exactly the scenario I was curious about here at Thomasville with the energy plant is how they did that because it was incremental, right? So the boilers and chillers and all of that were in similar timeframes, but I wasn't sure if that was depreciated as a entire entity or not.
Again, Melinda can tell us the truth, but my guess is the boiler plant and the chiller plant are probably two separate projects. But like the individual assets in those plants are probably not being depreciated individually.
Right.
So, Jeff?
So
Oh, sorry, go ahead, Will.
theoretically, the only way to capitalize anything in that room, even if it is two separate buckets, would be to depreciate the full asset cost.
Not necessarily. So like I would say if you're replacing something in that room, if you're replacing an asset that was installed during that project, yes. But if you're going to add an asset to that space or if you're going to, modify it, it's probably different.
Okay.
And that's where this conversation can get very one-off, like what's capital and what's not. And so, Jeff?
I've got a question that on the depreciation, is there like a set standard? Okay, as an example, I'm getting ready to quote a nourishment room, and the millwork was probably put in the 70s. It's tore up, this, that, and the other. I mean, is there some way that they look at that and say, okay, that just needs to go, we need all new in there? Or
Yeah, I would tell you that most depreciation schedules probably aren't more than 30 years at most, right? So something that was installed in the 70s is certainly not going to still have it's just going to be fully depreciated and can be replaced. And again, that's where it gets a little like, whatever part of the building you're in, like that whole renovation or that whole project could have been depreciated together. So like an example of that is when we did the Presbyterian A B kind of ABC wing renovation project a few years ago. That was the I think it was 3, 4, 5, and 6. We did each of those as a separate project, like 3A, 3B, 3C, so that they were not all kind of lumped together. So
I was going to share this.
there you go.
This was a schedule that actually came from some of our fixed assets team, or Madison Williams, who's on Melinda's team. And you mentioned millwork, and they've got right here 15 years. This is a list, and I don't know what all these fenestrations mean, but I see automatic doors, barn doors. I mean, it's got a lot of different things.
And again, look, from the American Hospital Association, as we referenced in an earlier slide.
I can share this if you'd like, but I just wanted to.
Yeah, I think that'd be good.
Okay. I'm glad to share it after this.
Luke?
So when they're looking at the yearly budgets then for operational expenses at each facility, are they actually looking at the depreciation that they have on file going forward?
Yep. So
So if that's not up to date, budgets are going to get messed up.
yeah, but depreciation's set once when a project's done.
Okay, so
Right.
like be at Ortho Hospital now from the 70s, the depreciation is pretty much done.
It's probably gone. Right here. Give me just a second. I can kind of show you that in real time.
Like
You're gonna
when
have
new
some,
things are added though, then they will have their depreciation.
You got it.
Okay.
it's
as
an
new things get
explainable
added.
variance. But it builds off a run rate, Luke. So like you'll see that month
Here, I'll
over
show
month,
you.
it'll update.
So this is the consolidated. These are consolidated financials. So let me go to, so like here's like well, let's go to an actual facility. Let me see if I can. All right. So here's New Hanover Medical Center, right? So here's, revenue, total revenues, here's all your expenses, right? And then you get that operating cash flow number, and then here's depreciation. So that's like an already determined number, right? So as an organization, we really focus on operating cash flow, right? Because these expenses up here, everybody considers controllable expenses, right? So as an organization, we can control revenue, we can control our expenses, and then you end up with this what everybody calls below the line, right? Which is depreciation, amortization, and interest. So you will often hear a term people use interchangeably with operating cash flow called EBITDA, which is earnings before taxes, interest, depreciation, amortization, right? So that's this operating cash flow. And then you have this depreciation that's set by finance ahead of time and just already baked in. So, David?
So with newer equipment, as it depreciates, does it automatically adjust in your budget for higher maintenance as it goes down the formula? Do they counteract, or is that just something you got to enter manually? Say, hey, this is 5 years down the road. This is 10 years down the road. I need to adjust because it's going to have more and more maintenance to keep it going.
Yeah, that it does not, right? So your depreciation goes down, and you have to make sure as you're doing your operating budget that if you feel like you need additional maintenance on a piece of equipment, that you're adding that to the appropriate line item in your budget. That's a great point, right? There's no, and I think one of the battles we fight, honestly, as we work through budget is exactly what you described, David, right? Like it seems intuitive to most people that as something gets older, it costs more to maintain. But it's often challenging to prove that to people. But I can tell you, like, our cost of operations at our older facilities is more than, and that's where this all this financial stuff can get a little, you can't look at one single data point, right? Because if you took all of our hospitals and compared their operating cost per square foot, you're going to see a couple clear delineations, right? One delineation is the three biggest hospitals, so Presby, New Hanover, and Forsyth, they are all going to be in a bucket together, right? Because of their size, right? So for those, size is more of a determining factor than age, right? So you'll clearly see that the cost per square foot for Forsyth, Presby, New Hanover is the lowest cost per square foot of all the hospitals in the company because of their size, just because of their scale, right? Then you get to like the small hospitals, and they're higher just because there's less square footage to spread that cost over. And then you're going to have like then like a Matthews and a Rowan. You can clearly see the difference in that, Matthews is 30 years old and Rowan's 70 years old, right? Matthews costs us a little bit less than Rowan. So the challenge, I think, David, with the financial piece is there's not like one single data point that tells the whole story. So if you just looked at the facilities by age, they're not all going to just cost more because of age. There's some other factors that make the costs come up and down a little bit as well, right? Part of it too is like how much deferred maintenance do they have, and how much capital have we, how good a job have we done planning and executing on capital projects that have made our actually reduced operating costs because we have replaced equipment. So you may get a really old building. So I would tell you like, my guess right now is Charlotte Orthopedic Hospital, Medical Park, and the New Hanover Orthopedic Hospital are probably our three higher cost hospitals because they're older. They have probably more deferred maintenance, and they have a very specialty service, right? It's mostly surgical, it's smaller number of beds. So I know it was way more than you asked, but I think when you get into the financial piece, it's you got to be careful that you're just not looking at one like metric or data point. So
I think that's one of the things we'll talk about later that's gonna be interesting. David, kind of ties back to your question you asked about it. Does it go up? I mean, when we start looking at, as you're evaluating even some of these projects or equipment, things like that, just looking at the total cost of ownership and life cycle cost analysis, but you figure in, for instance, like that maintenance, you figure it in per year and say, okay, we're gonna have $25,000 a year to maintain this piece of equipment. So you kind of build that in as you're evaluating piece of equipment. Some require more maintenance than others, so you got to weigh all that out. We'll get deeper into that later on here in the presentation, but that is something that does come into play as you're evaluating options.
So this is a really good discussion, guys. I mean, this is the whole intent is for you guys to ask these questions and have these conversations. So I appreciate it. Given that though, Lindsay, how are we doing on time?
I was going to suggest we take a break, and then coming back from break, we have this discussion question,
Okay,
and then we can finish out this section and check in about an hour or so. Is that okay?
sounds good.
All right, take a 10-minute break.
All right, be back at 9:06, guys.
Lindsay, I'm not sure if you all have to let me back in. I'm gonna try rebooting one more time, disconnect my docking station and everything, and see if I can get this camera to work.
All right, thanks, Jeff.
Okay, thank you.
There you are.
Sorry, I have no idea. Doesn't make sense.
That's all right.
It rarely does, Jeff.
Well, they said they
Oh,
would ask.
you got it working though.
Yes, I don't know what.
Well, yesterday I had to switch between docking stations, so I had to take my wife to emergency room early yesterday morning. Her back is shot. So, I just went and checked on her. She's pretty bad shape today. So,
Yeah, so this.
anyway.
Yeah, she's.
I switched and used her docking station.
This is with EV
I
chargers.
don't know if that
I guess
messed
they
it
got
up.
two somewhere. I'm not sure exactly where they're here or where. Yeah. No.
All right, before we left off, we had a discussion question. I put it in the chat. Here it is again. What factors do you consider when deciding whether to purchase a new asset? So that is where we'll
What
pick
do
it
you
up.
think? What would before oh, there we go. Age, cost to maintain, functionality. Yep. What about like continuous operations? Right? Sometimes we kind of get stuck, right? We have to fix something because there's no way to replace it. Or you have to come up with a longer term plan to be able to replace it. What else? Come on, you guys have all decided to buy a new washer or a new dryer or a new refrigerator. We don't have to make this super complicated. Everybody's decided to buy something new at some point. Safety, that's another good one. David, oh, got a whole bunch of hands up. David, why don't you start?
Just kind of thinking like the lemon law here. So what if you got something that you anticipated to last 15, 30 years and it has, like Brunswick example, but after 7 or 8 years, it's just not cost efficient anymore. And you haven't hit fully depreciation yet. So I guess that's one decision you got to make.
Yeah, I mean that's a great so let's just call it what it is, like break, replace, or run to fail, right? I mean, if something's failed, David, to your point, sometimes you may not have gotten what you wanted out of it, but if it's not functioning and you need it to run the building, you gotta that's a great reason why you gotta do it. You gotta keep operational continuity. Jeff?
I was thinking like operating efficiency. Everything's getting more efficient and using less power and
Yeah, absolutely. Operational efficiency is a great example. Joe?
So from just an overall budget situation, and I know there's going to be, extenuating circumstances, but do you need to wait for the depreciation to be at a certain level before you can go ahead and put in for a capital expense to replace that part?
So the answer to the question is yes. Typically, to use capital, the asset has to be fully depreciated. I can count on one hand the number of times we've replaced an asset that hasn't been fully depreciated. And to David's point, it was really around a piece of equipment that just didn't function right, and we had it long enough, but the manufacturer really wasn't willing to do anything. And so typically we are fully depreciating assets before we have to replace them. It's very rare that we don't. So, Alec?
Hey, I apologize for this question, but we're answering the what factors do you consider when deciding a purchase for a new asset?
Yep.
Correct?
Yes, sir.
All right. So I definitely think compatibility with existing hardware or devices that you already have present.
Yep. Yeah, it's really important, right?
Yeah.
John Patterson popped in there, life expectancy, warranty, code compliance, serviceability, right? Those are all things, we've had pieces of equipment installed that all of a sudden the manufacturer goes out of business, right? You can't get parts, you can't get service. and it's, typically something one-off, you just got to replace it. So, Luke, I think you had your hand up earlier, didn't you?
Do we have money for it?
There you go, right?
But I'm
yeah.
sorry. I
Go
keep
ahead. No, go
thinking
ahead.
about this though. Like we talk about the capital and we talk about operational, but when it goes all south and we have that emergency, does all that get figured out afterwards? Like they're
It
not
should.
sitting there
So here's my general
stressing.
guidance, right? My general guidance to all of you is if something is broken that is impacting our ability to provide patient care or safety to our team members, our number one priority is to get that situation mitigated, right? And get that mitigated, and then we'll figure out what comes next, right? Um, uh, Often, right? Like that means, Luke, we're fixing something to get it just back to operational, and while we're doing the capital to get the replacement for it, right?
Yeah.
And the way kind of we have our capital allocation, like I talked about the infrastructure bucket of money. So the way we plan to spend that money, because otherwise John Patterson would spend it all in the first quarter. But anyway, he's not paying attention, I guess. So, the way we try to spend that kind of money is we plan the projects out like on a quarterly basis. So like every quarter, we know we're going to execute on certain projects. So with that, and we hold a contingency. So what that does is if an emergency comes up, it allows us to replace a project that's at the bottom of this year's priority list to take care of that emergency. So we're not kind of overspending our budget. Like we can work, and that's worked really well where we hold, a couple $1 million for contingency. And then as we work through the year, we try to use that contingency, and then if that contingency is gone, we can move projects up and down. But yeah, I mean, from an emergency standpoint, absolutely we got to do it and get it fixed. From a proactive standpoint, your question is absolutely valid, which is like, hey, can we afford to do this? So, go ahead, Joe.
Yeah, so you brought up contingency. So is there a limit that you can plan the contingency account to buffer against unexpected issues? Like, is there a max 5 million or whatever in a contingency for a
No.
project, or is it?
No,
based on
no.
the-
I mean, so I think you have to be reasonable about it, right? So like, if you could hold all your money in contingency, right? And then you're not doing anything proactively, you're just fixing what breaks, right? So I think what we have found over the years is just from historical work, right? If we have $2 to $3 million of contingency on our infrastructure capital bucket, that gives us enough money. On an individual project, we know like early on in design, we'll have a 10% contingency. And then as that design of that project gets further developed, and we start getting to where we're procuring equipment and stuff, we can go into a project with like a 5% contingency or a 3% contingency. One of the challenges you run in when we talk about trust from that contingency standpoint is if you go in with too much contingency, right? So let's just say it's $100 million project and you're carrying a 5% contingency, it's $5 million, right? Most people are like, oh, well, if I don't use that contingency, if I don't use that contingency, that's money I'll give back. But which is true, right? But it's also money that can't be used for something else. So you don't want to have so much contingency in a project that you're delaying other projects. So it is a little bit of a, just making sure you have enough to be comfortable, but not too much. Well, great discussion, guys. Appreciate it.
And I would mention, you're talking about, I've got a chart that shows, if you want to see it, let me see if I can share this real quick. Lindsay, do you mind if I replace it? Okay. Here's a chart. Let me zoom into it a little bit. And this is just something we use with construction projects, but these are different types, and this was just a matrix. And Lindsay actually attached this file, which is a capital budget summary that we use. Considers pretty much all the items that we would typically put into a construction project. But one of the last tabs in it is this contingency matrix. And a lot of times, we're budgeting. And again, I'm not on the plant engineer side. I'm in the design and construction. So I think more a lot of times about construction projects where I know a lot of the questions I'm hearing are about replacements for equipment. So I'm thinking about a new hospital or a new wing or a new clinic. But a lot of times we budget, and I know it shows 10. I've actually gotten to where a lot of times now, if it's just a square foot estimate and we're basing it on something that we've done before similarly, I usually budget a 15% on a square foot estimate. But then when we start getting in and we actually get down to a bird's eye view plan or a schematic drawing that's just a single page, now I actually know how something's laid out. Then most of the time I go down to a 10%. I know this says 10, but most of them, again, I need to update this to 15. But then as we get further into drawings, and we get this, what we call design development drawings, which shows all the MEP systems and all that, then, or starts getting into the MEP, I might go down to a 7.5%. And by the time we get down to the final set of drawings that's issued for a permit, and the general contractor is engaged to the point that they've got subs on board pricing, then I typically go down to a 5% contingency. So I don't know if that helps answer what you were asking, Judge, but it does. It varies at different levels. So if you're thinking about in even in an operational budget, you still got to carry some buffer in there. I don't know how you would figure it in an operational budget. I think it depends on how risky, how much you've seen. Has this equipment failed a lot in the past? But it may not be to the point that it's been depreciated to the point you can replace it. So you might have to carry a little more if it's a risky piece, or I would say even possibly if it's a super. I mean, everything's important to keep running, but how critical is it? How critical is that piece of equipment to the operation of the hospital? All right. Evaluating new equipment technology. I'm trying to get my stuff up here. All right. When you're evaluating this stuff, I mean, one of the quick questions, or there's a few questions you ought to ask just to decide and make sure it's worth the investment. But one of the first things you got to figure out to decide if it's worth upgrading is just understanding what problem you're trying to solve. I mean, again, like Matt mentioned, sometimes you're replacing just a component in a air handling unit stuff, a fan or something, not replacing the whole unit. So is getting new equipment the best way to do it? And in that case, if you can replace a small component versus the whole unit, then it's not. And then you need to think about the benefits. Again, a lot of these I'm looking at, my notes pertain more a lot of times to newer construction. So I'm thinking about benefits. Will it help make your processes smoother, or cut cost, or even bring in more revenue? So a lot of times in our projects that are going to our capital allocation committee and to our board, they want to see a pro forma, which is a business plan. It just shows how this thing's going to work. I don't know, Matt, is that used when you're talking equipment replacements?
So on equipment replacements, they really they give the different subject matter experts a lot of latitude, right? So within like the medical equipment group and within the imaging group, that's a lot of the clinical engineering team and the operations folks. And then within facilities, it's a lot of, we get a lot of latitude within Tim McMurtry's group, and to kind of figure out what goes where. So it's not necessarily as important, but certainly something we'll evaluate, and we have to prioritize projects every year, right? So where do we spend our money is really important. So we do need a lot of that information.
Yeah. Then the other thing was something Alex mentioned, and it's important to consider how it fit into your daily operations with your current systems. You just got to make sure, it works with current systems. So that's the thing. And then another thing to look at is just the risk. You just want to make sure that it meets all regulatory requirements. As Matt mentioned, sometimes some of the vendors, I mean, they change frequently, gone out of business. So you want to look at sometimes the vendor's reputation. So I think that's a big thing as you're evaluating the equipment technology, looking at those vendors and seeing how they stack up. And I guess I looked at this slide more as, again, evaluating two different pieces, comparing. So maybe more than just deciding whether it's time to replace it or not. So you got to make sure both. All righty. Comparing the cost, the financial factors to consider. So when you're comparing the cost, you got to look at the full financial picture, not just that upfront cost. A lot of times, just because something's cheaper does not mean it is overall a better value. So some of the factors you can consider are like the total cost of ownership. I know I mentioned earlier, we'll get into that, but you got to consider not only just the initial capital investment to buy the piece, but you got to think about the upkeep, those service plans, maybe annual maintenance agreement stuff, the energy that it's going to consume, and then just how long is it going to last? How long before we're going to need to swap it out? And those expenses, you add all that stuff together, gives you that total cost of ownership, and it helps you to consider, what the whole thing's going to cost you over 10 years or whatever it may be based on that depreciation schedule. You also need to weigh financial benefits. Will it help make you more money or cut down on those expenses like the utility? I mean, is it a lot more efficient? Or keep things running smoothly without interruptions? Because every time we have let's just say we got a CT machine that's down on a regular basis, every time that thing's down, we're losing revenue because we can't, not that making money is the big thing. I mean, taking care of patients is the most important thing. But if the system's down and we're also losing money during that time, and then you got to think about, instead of just price when you're comparing these costs, you got to think about how durable and reliable the equipment is. So I think that pretty much covers what I wanted to address there. Let's see. All right. Once you've figured out your upfront cost, next step is just to do a quick financial checkup. There's a few ways we can do this. You can crunch these numbers like we talked about earlier. A lot of times you got to look at it from several different angles. You can do it by calculating. It really depends on how your finance people or the decision makers, maybe not necessarily finance, how they want to see it. You can do it by calculating a return on investment, or you can do it by life cycle cost analysis or net present value, which these are all, we'll get into in the other slides describing each one a little more. But you also, outside of look at those, you need to really consider what it means by if you don't invest. And I think we hit on that. I mean, if you don't invest, your maintenance costs are probably going to be more. But that's called the opportunity cost. What if I don't invest? And it can be as simple as the revenue that you're going to lose because that CT scanner's down. You might lose tens of thousands of dollars in procedures and reimbursements, or patient satisfaction. I mean, if it's maybe a rooftop unit or something that's not functioning right, and patients are hot in the summer, cold in the winter, I mean, they're not going to be very happy. Or back to higher operating costs. Again, if it's consuming more energy, then or require frequent repairs, that might be an issue. So you got to look at all the pieces together to help find the right balance to help make those smarter decisions. Before moving forward with any of these, any capital project, you really need to figure out what success looks like to you. You can start by identifying the goals and objectives. So what do we hope to accomplish from this project? Then you need to identify deliverables. What are the real results of the project going to provide to the organization? And then just identify some of the requirements. I mean, what are the absolute must-have things this thing is going to do? And then document those into a scope statement. And that scope statement needs to clearly include, and that's going to kind of tie back to those got to have things, what's included and what is excluded. I know in a lot of the estimates that I put together for new buildings or new upfits, I mean, I clearly try to state what is included and what is excluded. I mean, for instance, if we're renovating let's just say somebody came to me, Tanya came to me and said, "Hey Jeff, we want to know what it's going to cost for us to upfit 10,000 square feet in this building. It's an existing building with a second generation space, but we're going to gut it and all that." Then I make sure that I list out in my exclusions that it does not include repairing or replacing any current faulty equipment. It does not include asbestos removal, things like that you might run into, things that you just wouldn't know. So I think your scope statement is important to include. Make sure that you've documented those things. So a good, clear statement with inclusions and exclusions. All righty. Lindsay, I'm sorry, I'm having to move through some of my notes at the same time. All right, so this one slide about factoring inflation into the financial decisions. So every financial plan needs to account for inflation. Even when you think you've got it all covered, because inflation will impact everything in the project. It impacts from labor to materials to software to, gosh, I think back to the sheet that I was talking about earlier, that capital budget summary. I mean, everything on there from the construction cost, our A&E cost, because the A&E is typically based on a percentage of construction. And it gets down even to our low voltage systems like the nurse call, access control, building automation. It affects the cabling of the building from low voltage, so all the IT cost. But again, it hits everything, I think is the key to that. Let's move to the next slide. So, but inflation really means is just saying that stuff gets more expensive over time. It's typically measured with the consumer price index, which they use the consumer price index is calculated by looking at just everyday stuff that consumers buy, like groceries, their housing, transportation. I guess that'd be cars, gas, all that stuff. And it gets updated every month. And a lot of economists, businesses, they keep an eye on how it's doing just to determine what the economy is doing. And it's really gives us a big picture of how the cost of living is shifting, whether inflation's up or down. Let's see, inflation impacts. All right, I want to, I got some stuff here I want to really hit on here. So generally speaking, inflation, it affects both your operating and your capital budgets. If things are up, it's going to cost more for service calls and repairs. If it's down, do it, but it's going to go up. It tends to go up every year. So inflation generally in a low inflation year, it's usually around 3% per year. But in a moderate, normal market conditions, we've typically, most people figure around 4 to 6% per year. I know in this slide, they mentioned that unless directed otherwise, assume a 3 to 5%, I guess, inflation or escalation in early estimates. I can tell you that in most of the estimates that I do, I do a 0.5% per month, or that's 6% annually. So I'm kind of on the high end of the moderate. And that's just because in most of the projects I'm estimating that they're looking at them to be something that's done a year or two down the road. I mean, again, back to like when Tanya was asking me, say, hey, Jeff, we want to know what it's going to cost to upfit a building that a developer is going to deliver 18 months from now, or she'll say October of 2027. So I got to figure out how many months I'm dealing with, and then I need to add escalation. But again, that escalation is calculated on the bottom line. It adds on to every component from the material, supplies, labor rates, and all that. And there were times, even though I'm saying we figure 0.5%, during COVID, we saw, so there's times those high inflation markets that we saw 1.75% per month, or 21% annually, that was driven by all those supply chain disruptions. I mean, it was crazy, Matt. But it kind of leveled out. I mean, we saw people, like, for instance, an upfit. We were doing upfits of interior spaces back then, prior to COVID. If we had a warm shell space for $135 a foot, just the upfit portion of construction, where that kind of leveled out, and the new norm is $225 to $240 a foot. So that's how much COVID impacted the new norm and drove inflation up. And in the next two slides, we're going to look at a real world here example. So this first slide, this is a slide where I was involved with a project that kicked off back in 2016 at Thomasville Medical Center. They had an old building that the county had owned. I don't know if we bought it, it was donated to us, whatever, but I know it was extremely old. I had walked the building a time or two myself, but in 2016, we were asked to put a budget together. And from 2016, and the scope of the project really didn't change. But from 2016, it started out at $2.7 million estimate. By the time we completed this project, which was in mid 2025, it ended up being $7.5 million. The reason the project kept getting delayed was the foundation was trying to raise money to support this project, but they couldn't keep up with the inflation. So we said, okay, it's going to be 2.7 million. So they're out trying to raise 2.7. And then they come back 2 years later and they say, hey, well, we've raised $2.7 million. Y'all ready? Let's start this project. Well, we kind of look at it then and say, oh, it's $4 million now in 2018. So they had a really hard time keeping up with it. And then you see big jump there in 2021, 2022, from up to 6.9. That's your COVID years. And then it kind of leveled back out in 23 and so forth. But again, scope didn't change a lot. It just, that just wanted you to see how it progressed from 2016 to 2025, or it shows 24, but when it was done. And in the picture here is just some images of it. You can see that old building on the left, and it was very, very dated, and what we made it look like on the right with our Novant branding. This thing, we got into it. It had been sitting empty for nearly 20 years. It had asbestos in it. It had the roof was we thought the roof on it was just gonna be replacing the rubber membrane, but whenever they pulled it off, I mean, it was rotten. We had to replace everything. So we spent a lot of money, burn our contingency out with this thing. So that pretty much covers that one, Lindsay.
Joe, did you have a question or comment?
Yeah, I did. Are adjustments made during a project after it's finalized? The reason I brought this up is that kind of when I first started working here about 9 years ago, we had some issues in the Women's Center with some of the plumbing as far as our hot water valves and whatnot. And there were not any shutoff valves where they needed to be in this project. And talking to one of the contractors, he's like, well, these were originally in the budget because of the process we had to go through after the fact to freeze the lines and install the valves were shut-off valves that we needed to isolate. To change out a hot water valve up there, it took a lot of time as far as repairs, and a lot of them were starting to be, it started becoming a real issue. And they said that was cut out of the project, those extra valves to isolate every individual box from a cost standpoint. So now I noticed that some of the recent renovations we've had, they're in there, but it is,
So a lot of times, I would tell you, a lot of times, I mean, a lot of budgets have been put together based on a previous project, what we thought it ended up costing. And again, if we don't calculate and think about inflation and we just say, okay, well, this last project we did, I'm just throwing out an example, was because I'm really thinking about a new hospital, was $1,000 a foot. And now the new number is $1,400 a foot. If we didn't really consider that inflation and stuff, then by the time the project gets approved and we're moving forward, we're already kind of behind. We didn't keep up with inflation, so we're have to start value engineering to find out ways to keep the project within budget. Because the money typically it's already been to board and been approved for a certain amount. The business the pro forma's been done based on that amount. And the certificate of need that where we applied to the state, we have to live within that amount. So a lot of times we're value engineering to try to find things that we can do to bring it back. And gosh, unfortunately, I guess I've talked about this before. I've seen this in looking at pay applications and talking to general contractors. You figure all the MEP systems are, a lot of that stuff's hidden in the walls, in the ceilings, in the floor, but it's 60 to 70% of the cost of the construction. So unfortunately, when you start trying to find ways to trim, it typically ends up coming back value engineering. A lot of times it ends up coming out of those areas. So
Yes. So it depends, Joe, but typically once a project is set and the budget's set, like we don't add money to it. And like in that particular instance, talking about the Women's Center, it's probably a situation where, much like this Thomasville project, somebody said, hey, you get $10 million to go do this. And that they had to kind of work backwards into what they could afford to do in the project. And, lots of times you end up cutting out components that would be operationally effective. It's kind of that there just probably was not an opportunity to add more money to that project.
Okay, so that's kind of what I wanted to know, if the adjustments had to be kind of made up front before the project, or if somehow they had to be manipulated during the project to help offset that cost.
Well, so yeah, during the project, I think we need to make sure we stay within budget too, right? So That's why we have contractual typically can carry a contingency, will can carry a contingency. But if you burn through all those contingencies, then you start having to work within the dollars you have to figure it out. So
But, and the risk, I mean, like I was showing earlier on that contingency matrix, the risk are on a net new are probably lower than because you're starting from scratch. I mean, you're not going to run into old things that aren't working that you didn't anticipate. I mean, yes, you could run into unsuitable soils and big rock under the ground stuff, but we do enough testing a lot of times to address that type of stuff. But that's the reason we start off with a higher number and then it slowly gets down to we reduce the contingency. But if you're on a net new hospital versus a renovation of an existing, I would definitely carry a more higher contingency on a renovation. There are too many unknowns. There are things that you discover. I think back to just some of the equipment replacement projects that I've done in the past. I used to always get a contract, or I'm trying to think what they called. It was a company that would come in and do a pre-construction test and balance. I just wanted to make sure that the mechanical units working in that area and stuff were functioning to the point that I could get the air exchanges that were required. If not, replacing a unit or something might end up having to be a part of the project. But a lot of times if you didn't have that balance, that pre-construction test and balance done, then you just assumed that the area was already functioning. It was already getting the air exchanges that DHSR was going to require for this type of area. So that was just my example for that.
Good deal. Thank y'all.
Mhm.
Luke,
I'm just curious to know, is there any way to plan for the tariffs that have been happening with this stuff?
so interestingly, we're just wrapping up a project at Presbyterian, and I got a note yesterday that the general contractor carried a tariff allowance in their pricing to us, and we're actually going to get all that money back. So, it's one of those pieces where it's like, hey, just like I was talking about earlier, you can carry that to be safe, but then it's like, well, could those dollars have been used somewhere else? And it's just very volatile. Like I heard yesterday that due to some of the data center demand that's out there, like steel and precast concrete panels are like, so precast concrete panels are like 11 months again, right, for exterior skin, and steel's like 35 weeks. And it's just because of other demand, right? So I still think tariff, supply chain, all that is kind of constant ebb and flow, and you just got to kind of roll the dice and make the best decision with the information you have at the time, and plug in what you may need to plug in, but not plug in so much that you like kill a project or you
Yeah.
take money away from another project. It's definitely a balancing act.
And that's the reason I said earlier, I use that 0.5%. I mean, they show the norm is 3 to 5% or in a normal year escalation. And I use that 0.5% or 6% annually. It's not excessive, but I do it consistently and can help explain why I did it. Because this is what the market shows the FCI, the consumer index. So I try to do it. I keep in touch with contractors to ask what they're seeing. But to Matt's point, I heard a lot about the tariffs. And out of all the estimates and stuff that I've put together and done or been involved with, I didn't see we didn't take tariffs into consideration. We just knew that it was so unknown what it was going to do to it that we just kind of rolled with it and knew that it was a risk. And if we had to deal with it, that we could explain that later. Hey, this is what happened because of the tariffs. And, there are times to go back and do it, but if you plan and budget so much on the front side for everything like that, you potentially will kill a lot of projects before they ever happen. So you gotta think through and realize again that inflation hits everything, but you got to be realistic too. If you go overboard, we wouldn't have, I mean, I could make sure that we had plenty of money to do every project. I say, okay, let's get for a clinic, let's get $1,000 a square foot, but knowing that they don't cost but 450 a square foot, but they would never happen, you know. So you gotta really weigh it out.
David?
I'm just curious if you were to, like Joe's example, cut those valves out of the project. Do you go back to your operating budget now, say, hey, we got an extra step or two in the maintenance process or servicing process of our equipment? Do we need to adjust that operating cost for the lack of whatever we didn't install in the project?
We hope so, right? So one of the challenges we've always faced is, it's this natural kind of push and pull with the operations team and the design and construction team, right? So we try to make sure the operations team is as involved as they want to be in these projects. And it's through nobody's fault, but just through how busy everybody is. Sometimes we don't engage people as enough from a design and construction standpoint, and sometimes from a plan engineering standpoint, we don't engage ourselves enough. We have the opportunity, but we don't engage, right? So I think the short answer to your question is, David, I would hope we are. Sometimes I think there becomes a little bit of a us versus them. And what it really is about, like, hey, we're all just trying to, like, the design and construction folks aren't purposely cutting out valves to make the plant engineering life like harder, right? It's just that was the least, unfortunately, right? That was just determined by, and sometimes when we're making value engineering decisions, those decisions are being made by like hospital leadership, right? So more important for them to have an extra bassinet than for us to have valves, right? Our perspective will be much different, right? So I think a lot of that's just us, the design and construction team and the plant operations team at every level just continue to work together and realizing that everybody is that everybody's trying to do the best they can with what they have, and we all don't have everything we need at the time, and we're trying to make the best decision we can. So.
And I think a good example would be like Scotts Hill. I mean, we had to cut probably, Matt, what was it, like almost $30 million out of that from the original number to get it back down to what the board had approved. So they had got, well, and we actually got a board increase, but we still had to cut money to get it back down. For one, we had to meet the certificate of need. I mean, the state will allow you to go whatever your original number was plus 15%. You can justify that. You can go up to 15% over, but you got to justify and show why. But if you're more than that, and you got to turn in monthly, or I ain't gonna say monthly, there's progress showing how the progress is going, where do you anticipate it being, the final spend, and so forth. And then they want to see it. You have to turn in a capital expenditure sheet to them. But we had to find nearly $30 million, and we did have plan engineering, design, construction, architect, even since we already had a GC on board. I mean, we had them at the table providing us estimated cost if we do this, estimated cost if we do that, along with their subs. So it was a joint effort. It wasn't just making a decision saying that we can do without those valves.
All right.
So I think we can move on to the next slide. So the next one's I don't know if you guys been involved with it, but we're going to be talking about the project evaluation methods. And have you used any methods to evaluate a potential asset purchase, even if you think about in your, and I always try to do this. I always try to think about in my personal life. I don't just try to Novant Capital. I may not call it net present value or individual rate of return or cost benefit analysis, but I do look at that stuff a lot of times. So any of you guys got any ways that have got any examples of ways you might have evaluated potential purchase? And Lindsay, I think that's down to the next slide where it's just what calculation methods have you used to evaluate? Alex?
I don't know if it really tracks, but in the last month I just became a homeowner, and
Mhm.
to do that, they had to do a debt to income ratio, and they had to make sure that I was making enough and that my debts weren't too high, and that I could afford what they were going to buy for me. So.
I think that's a perfect example. It's not exactly a piece of equipment, but you got to make sure you got the funding, the money to support to make that pay it every month. Don't get yourself in trouble where you go have to shut the doors. Well, like I said, mentioned there's several ways that they can be looked at. I mean, again, I mentioned a few of them. Net present value. We're going to talk a little more in detail about these individual rate of return, cost benefit analysis, payback period, return on investment. But really, the best method just depends on how big the investment is and how detailed the analysis needs to be. So that takes us down to talking about the next slide was more about um, the well, I'm going to talk about first the asset life cycle. So the asset life cycle describes the full journey of an asset. It's from the time that you buy it or purchase it, PO's issued, to when it gets used, how it's maintained, and then even eventually disposing of that asset. So I think a lot of times about, I mentioned earlier, like CTs, MRIs. I've done tons of equipment replacements through the years. I mean, at the end of that project, that piece of equipment, and we'll get into a little bit later about this life cycle cost analysis. But one of the things at the end you actually have to figure in is how much is the value of that piece of equipment when you're disposing of it, and even when we do certificate of needs, we have to. There's a I can't think of what it's actually called in there, but I think it's a disposal fee or the value that it's got at that moment. So but the full life cycle, again, basically these bullet points at the bottom is from acquisition, not accusation, acquisition through disposal. So you got to look at the full life cycle to, um, determine that cost, so the total cost of ownership. So total cost of ownership, um, the life cycle cost and the total cost of ownership, they're closely related, but they're just a little bit different. The total cost of ownership is used to understand the complete picture of the ownership. And like I mentioned, it covers not just the upfront cost, but the full cost to own and operate something over the useful life of it. Even from the energy use, repairs, training, those were all some of those bullets that were in the middle there. So got to look at it. It just helps to figure out what the asset truly cost us to own over time. And then when you get the next slide on the life cycle analysis, it is, like I said, very similar to the total cost of ownership, but it is considered as a decision-making tool that's used to compare the cost over the entire life. And usually it's when I say decision making, it's usually where you're comparing a few different options. So you can determine which one will cost less in the long run, not just today. So not just the purchase price. And there's a formula shown here to figure out really what that present value is. You got to take the capital cost, which would include your purchase price, installation, and setup, plus the maintenance cost for the routine items to keep the whatever that piece of equipment is working properly, plus the energy cost, which could be fuel or electricity, water, whatever, over that system's life. And you kind of got to know how many years you're dealing with, and plus estimating any major fixes or component repairs. So let's just say that the Matt, you might have to help me here, but I don't know like what the lifetime of a chiller is, but there might be certain components of that chiller that may not, even if a chiller is supposed to last 20 years, there may be certain components of it that only last 5 or 10. I don't know. So I'm just thinking about those could be things that you'd figure in as those repair replacement cost over time.
Yeah.
But
No, you're absolutely right, right? There's certain components and certain maintenance that needs to be done, even of small components on a large machine on a regular basis.
yeah, I think about like your truck analogy. You're still going to put tires on it. I mean, the truck itself might last 300,000 miles, but you're probably going to put tires on it every 50,000. So those are some of those replacement costs. And then you figure it, then the last thing to figure out that life cycle cost calculating that analysis is the salvage value or the remaining value of the asset at the end of its life. And you subtract this because it's money that you might recover. I mean, you could sometimes on a piece of imaging equipment, and when they used to come in and we would get a company that would come in and buy that piece of equipment. They might buy it for parts, but it was money that we would actually recover at the end. It might not have been $5,000 or $10,000, but you do have to deduct that salvage value. So that is life cycle cost analysis.
So I think we talked about depreciation a little bit earlier, but as you can see, this example, the math's done for me, so I can walk through it a little bit easier. $600,000 chiller, 15-year life, right? So that take the 600 divided by 15, you get $40,000 per year. So again, like we talked about, even though we paid $600,000 to a chiller, on our expense, like that expense doesn't show up because it was capital. It shows up in that depreciation line over the life of that chiller. And once it's fully depreciated, it goes away. Depreciation goes to zero and you're done, right? Because you fully accounted for it. Next thing is average age of plant. So this is a number that gets used a lot by finance teams, right? So our fixed asset team could do this. And this is really just age of plant. So again, this has nothing to do with actually how old anything is. This is a mathematical calculation based upon depreciation numbers. So it's the amount of accumulated depreciation divided by the depreciation expense. So you can see in this one, if a system has $100 million in depreciation and we depreciate $10 million a year, the average age of plant is 10 years. So, again, the higher the number, the older your infrastructure, right? So, if you're depreciating at a lower number, you're going to get to that where you want to be in that 10 to 12 year range. Once you get above 15-year average age of plant, it's when again things start to break. It impacts reliability, cost, etc. Will?
Do we always depreciate evenly over the expected life of the piece of equipment?
Yes. Yeah, I'm not aware of anything where we do like bonus depreciation where we take more out of it in the first 5 years or something like that. Typically, ours is just all straight line depreciation.
I think that Excel sheet that you showed earlier, Matt, wasn't that depreciation? That was like an annual depreciation.
That was just the depreciation expense.
Oh,
right?
okay.
That was the depreciation expense for that month, right? So that number could change monthly depending on where things are depreciated or not. Will, do you have another question?
No, I think it was just
Okay. Okay. So again, this age of plant ratio calculation, accumulated depreciation, depreciation expense. So we have 10 years of accumulated depreciation for every 1 year of expense. So how much depreciation are we accumulating divided by the amount we're actually expending? All right, so internal rate of return. Internal rate of return is another financial metric, and it shows the return rate the project is expected to generate over time, based on the upfront costs or the savings or revenue. So often the IRR for infrastructure projects is zero. You kind of have to get a little creative with this. So as an example, on a growth project, if you're going to go add a new hospital or a new clinic or a new service, the current or currently the organization requires a 12% internal rate of return for your project to move forward. So an example here is, we have a new energy system, costs $1 million, but we're going to save 120,000 in energy costs. So we'll calculate the internal rate of return on those numbers, because it's really it creates this how much we're saving over the life of the project, just like the interest rate you would get on a savings account, or other interest bearing account. Net present value is the net present value is how much money you're going to bring in or save over time, and it adjusts to today's dollars, right? So because a dollar today is worth more than it's going to be in the future because of inflation and all those things you just talked about. So it helps us by answering the question, if something has a negative net present value, it's probably not worth doing, right? You want a project to have a positive net present value over its life. So this gets really important when you're doing like long-term projects that have much longer life expectancies, to make sure that project still makes sense. Because the money could be used, if you have a negative net present value, you're better off putting that money into something else, right? Today's dollars into something different.
And Matt, I'm sorry, I skipped over hurdle rate. I know you said that an IRR of 12%. Did you want to talk any more about hurdle rate, or are we good to move forward?
Oh, I think we're good.
Okay.
So net present value example, we'll have a project that saves 50,000 a year in energy costs for the next 10 years. So the accounting for inflation risk, the hospital's cost capital, those future savings are only worth, $380,000 today, not 500, right? So if the project costs 300, then we have a positive net present value. It's a good investment, right? If it's negative, it costs, like we talked about, costs more than it's worth, and once we adjust those savings for the future in today's dollars. So just double check something. Yeah. All right. So some other key financial measurements are cash on hand. So how many days of cash do we have? So Novant tries to be somewhere between 150 and 200 days of cash on hand. So that means we have enough cash. If no money came in for the next 150 days, if we literally brought in no dollars, we could still pay all our bills. Debt covenants. So Novant, like most not-for-profit systems, instead of going out and getting a typical loan, we sell bonds. And those bonds, like any other loan document, have certain, just like Alec was talking about with his, debt to income, right? We have similar things for Novant, right? Like there are certain parameters we need to maintain those debt covenants. So again, minimum operating margin, limiting the amount of debt we can add, enough cash on hand. And then if we break that covenant, it could cost us a penalty or our ability to get future debt. Another important item is bond ratings. So you've probably heard of Moody's or S&P. They are just like your credit rating, like your personal credit score. They give us a credit rating. You want a high credit rating. You want to be in the A category. I think today we're AA, or it depends on the rating agency. And then that's what gives us the ability, like our credit rating is what people are interested in, right? Because we have a high credit rating. They want to buy the bonds we're selling to do projects. They want to lease. They want to be our landlord because we have a good credit rating. And when they go to their bank to get their funding for their project, they know that having a good tenant is going to help them. So that's something we're doing on a regular basis. Quarterly we report information to the rating agencies, and it's really important to keep that credit rating high, just like you want to keep your personal credit score high.
All
Good.
right. So,
Go ahead, Jeff.
a cost benefit analysis, this is a tool that helps you compare all the costs to the expected benefits. So it weighs the overall value, not just the dollars. So it looks at both financial benefits, like the potentially energy savings or the reduced maintenance cost, even in maybe if you got improved patient throughput, which means you're going to see more patients in an amount of time that you've allotted in a day. And it also looks at non-financial benefits such as better satisfaction, lower patient risk, or even meeting regulatory requirements. And the net benefit is calculated by subtracting the total cost from the total benefits. And if the number, like I think Matt mentioned this one earlier, if the number is positive, it means the project's benefits outweighs the cost. So it's considered a good investment. On the other hand, if the net benefit's negative, it might be best to hold off on this one since the cost outweighs the gain. So in this example, Project B has the highest net benefit. So, but you can see in Project A, we took the benefits of 120,000 minus the cost of 100,000. So the net benefits was $20,000. Where in Project B, we took the benefits of 180,000 and the cost of 150, even though we're investing more up front, it's the net benefits is 30,000, so it makes that a better option. Conducting a cost benefit analysis, the steps to do that. Number one, you got to figure out the cost and the benefits that are involved. So you got to list those out, figure out what they are. Then you got to put a dollar value. You got to assign a dollar value to both of them. Then you can use that formula to calculate the net benefits, which again was taking your total cost, subtracting the total cost. Wait a minute, subtracting the total cost from the total benefits. Yeah. And then you can compare those benefits across more than one option just to figure out which one is the best value. Cost benefit analysis example. Hold on a minute. I'm sorry. Okay, so upgrading air handler units. If that saves you $20,000 each year in energy and $10,000 a year on repairs, that's just a straight $30,000 every year in savings. It can sometimes offer even some non-financial benefits like we were talking about. It helped reduce noise, meet new ventilation standards, and make patients and even staff more comfortable. So even though those benefits are hard to measure in dollars, they do make a difference. So doing that cost benefit analysis isn't always just about financial targets. It definitely impacts a lot of other things, and you got to look at everything, and it helps make decisions like repairing versus replacing or leasing versus owning. You got to look at all that stuff to figure out what makes sense. And then the payback period is the amount of time it takes for a project to pay itself back or break even on its original cost. There's two different ways to calculate payback period. There's a simple payback period, which just calculates how many years it takes you to recover the initial investment. But the thing about it is it doesn't consider the changing value of money over time, or we talked about inflation. So makes it pretty easy to calculate and understand, but it just with it, since it doesn't calculate inflation, often it's not accurate. But you can go with the discounted payback, which just takes it a step further, and it still takes how long it takes to recover, but it accounts for the fact that money received in the future is worth less than it is today, and it gives you a more realistic picture of the payback. Return on investment, just a simple way to look at this is just for every dollar we spend, how much are we getting back? It's shown as a percentage, which makes it easy to understand and compare different investments. A higher return on investment means the project provides more value for money, while a lower percentage just means the return is smaller. And you can see that formula there where you're taking the return on investments, the total benefit minus total cost, and then dividing it by the total cost, and then multiplying that times 100 to get a percentage. Project evaluation method summary. Like I said, there's several ways you can evaluate the projects. I mean, listing down the left there's our net present value, the individual rate of return, CBA, and all that. But the net present value it just measures the value of the project by comparing today's value, future cash inflows and outflows. The individual rate of return is just looking at when a project breaks even. Generally, the higher internal rate of return is just a more attractive investment. The cost benefit analysis compares a project's total cost to its expected benefits. And it does look again at both financial and non-financial, so things like patient satisfaction and so forth, and where you got to add values to each one of those. Then the payback period, which I know we discussed every one of these slides earlier, but just looks at how long it takes for the project to recover from initial cost. But each method looks at it from a different angle, and sometimes you use several of them together. It just helps give you a better picture to determine whether it's a smart investment or not.
We've been going for about an hour since we took our last break. So I wanted just to check in. We are a little over halfway through the presentation, so we're doing well on time. Is anyone up for another break? Or
I am.
you're like, yes. Great. So like another 10-minute break? Would that be okay?
Perfect.
Yep.
Cool.
All right. Thank you.
All right. You all ready to get started again? Should we do some math? You ready for some math, some fun math? All right, here we go. Fun math, operating margin. So if a hospital generated 12 million in revenue and had a 11,700,000 in expenses, what is their operating margin? Just in dollars, you don't have to do it as a percentage. So you had go ahead, Alec.
Would it be 300,000?
You got it. That's correct. Right? So, and then if you just wanted to do it in a percentage, 300,000 divided by 12 million, it's 2.5%. All right, so this is where it gets a little more complicated. So 2023, our operating margin, Novant Health's operating margin was 1.77%. If we have to do a $22,000 repair, how much revenue do we need to generate to cover that expense? So, you know, for every dollar of revenue, we're essentially getting 1.77% of that as margin, right? Does that make sense? So if we made $1, do some math here, $1 times 0.0177. Yeah, that's like essentially for every dollar, that's almost 2 cents, right, that you're collecting. So if we had, so what you do, if you take the 22,000 and you divide that by the margin of 0.0177, we'd have to make $1.2 million to pay for that $22,000 repair. So we'd have to collect $1.2 million in revenue to pay for that $22,000, because for when we bring in that 1.2 million in revenue at a 1.7% operating margin, right? So if you kind of do it in reverse and you take your 1.2 million, which it's 1.42 actually, and you multiply that by 0.177, 0.0177, that's $22,000, right? So that's the thing we got to think about, right? So for every dollar we spend, right, if you're operating at a margin, for every dollar you spend, you got to bring in a lot more revenue to pay for that dollar, because you're not making, you know, you're not collecting every day because you have expenses, right? You're not collecting every one of those dollars. So kind of coming to those questions, why do you think, you know, even small expenses can feel big in low margin environments? Right. We just did the math, right? You know, for us to pay for a $22,000 repair, we had to bring in $1.2 million. It's pretty significant, right? So that's why like even small numbers can add up really quickly. So in this case, what kind of projects? So think about margin, right? So we're trying to grow our operating margin. So what kind of project do you think is the easiest to justify project?
One that makes money.
With a high operating, and a project that makes money has a high operating margin, right? So you can have a really good project. So like that's one of the challenges, right? Is we talk about different financial metrics. You can be the largest revenue generating health system in the country and lose money, right? Generating revenue doesn't create margin, right? You have to make money on what you're doing, right? So you have to generate margin. So your revenue growth and your expense management have to coincide, or otherwise you can grow your revenue unlimitedly, right? But you're spending more than you're gonna make. So we got to keep some money in the piggy bank for a rainy day. All right, so just a couple examples, CapEx or OpEx. So filter replacement. Come on, just yell it out. No raised hands, just yell.
OpEx.
OpEx, good deal. New chiller.
CapEx.
CapEx,
CapEx, that's right. Staff uniforms.
OpEx.
OpEx,
Yep. Controls upgrade for 15 air handling units.
CapEx.
Yeah. I would classify that as CapEx. That's one that could get a little fuzzy, right? And you gotta say the right words to the fixed assets people sometimes to get them to understand the accounting, but or get them to account for it correctly. But yeah, that I would say it's generally a CapEx. Light bulbs,
OpEx,
OpEx. Yep.
But what if you were doing a whole system replacement from incandescent to LED?
Well, let's go to the next one. LED retrofit of entire campus. That would most
CapEx.
likely
I'd
that'd
say
be CapEx.
CapEx.
Yeah. Yep. Yeah. So again, like when you and again, it gets a little. Some of these get a little weird, and you gotta because like when you do the lighting, it doesn't hit the capital thresholds, but when you do all of it together, it does. So it all depends how the project is put together. All right, so life cycle cost analysis. So does everybody have a piece of paper and a pencil? Kind of, we can walk through this together. So what is the nominal life cycle cost of this piece of equipment? So it's,
This is,
go ahead.
no, I'd say this is one I ran through where you gotta add all these up, but you gotta take your years into consideration. So that 20 years is very important in calculating some of those things.
All right, so it costs 500,000, right? So that's one, right? First thing we got to add up.
Mhm.
Second thing we got to add up is annual maintenance, right? So we're doing a life cycle cost. So what do we have to do with that $7,000?
Times 20, 140,000.
There we go.
Yep.
And then we got an annual energy cost times what? 20 times 20, right? 20,000 times 20 years.
400.
Yep. So we got replacement parts over the 20 years. So remember, that's over the 20 years. So now how much do we have to add? Somebody yell it out, man. You guys know the answer. 50, right? Because we know that's over the 20 years. Okay. And then it's salvage value at the end of 20 years. So what do we have to do with that 25,000?
Minus it.
Man, we're on it. So somebody have a total for me?
1.115 milli. Oh,
I think we
plus the 500, so 1.6 million.
I think we mathed wrong somewhere, or what I have for the answers. It's close. You're close. So we got 500,000 plus 140,000, right? Go ahead, Lindsay. Oh, okay. That's 640 plus another 400 gets us to 1,040,000. Plus 50, right? Gets us to 1,090,000. Minus 25,000 gets us to 1,065,000.
That's
So
what I got to.
does everybody understand the math? Like not the like basic math, but like what we added and subtracted and why we added and subtracted it. Like I know you understand the basic math. Any questions about that? So like a good example of this is an old example. So 20 years ago, like when I was doing engineering design for schools, cast iron boilers were pretty much the standard. gosh, condensing gas-fired boilers were like the new rage. But the reality was, like a cast iron boiler, you could set in place, install a thing, and let it run for 30 years and essentially, tune the burner once a year and be done with it. The condensing gas-fired boilers required a lot of regular parts replacements, right? So as these schools are doing their life cycle cost analysis, the condensing boilers were far more energy efficient, but the maintenance costs over time were much greater for them, right? So that's an example of where you may want to, where you're going to do this analysis. All right. Let's see. What's next here? Internal rate of return. So, I need a slide.
I'm sorry about that. I was waiting for the discussion question on the last one, but Caitlin is here. I'm going to pass the mic to her. She's going to take over and drive for me. So great to see you.
Good to see you all. Thanks, Lindsay.
Thanks.
Yep, thank you, Lindsay.
All right. So on this one, we're considering a $300,000 investment in a new energy upgrade. And we have these projected returns over the years. So this is just simple. We're not taking into account any future stuff. So, our total return on this project is the sum of these 6 years worth of work, which is $320,000. The project itself, right, is going to cost us $300,000. So our overall savings is $20,000. So if we take our $20,000 and divide it by 300, we get a 6.67% return on our investment, right? So in this case, if we could take the $300,000 and invest it in a mutual fund, stocks, something that made 8%, that's better than doing this project, right? Or if there was a clinical project that had a 10% return, it would be better than this 6.67% project.
So are they looking for a certain rate of return on this stuff?
So on the internal, so they don't necessarily look at just the pure return on investment. They're looking at the internal rate of return, which is a little slightly different calculation, but 12% is what we're going for because we want to run at a 10% operating cash flow, is really where we want to be. So we really are looking for projects that have 12% internal rates of return to move them forward. Now that's on new services growth, those types of things, like all the kind of routine capital that we have to do, like, replacing a chiller is never going to get you there, right? But when you're comparing two projects, like for growth, they're looking at 12%.
I think even if we don't invest in this one, we might have to use some OpEx to replace that thermostat. Things a little mangled.
Sure is. All right. Let's see. So, which evaluation method for each project, right? So, we're doing a, controls upgrade. What are we're looking at replacing an outdated building automation system. We have a cost, we have expected benefits. What do you think we're going to look at on that one? It's probably just straight payback, right? It's pretty straightforward. Like, what's the payback on this, right? So, it's going to cost us $15,000 and it's going to save us $9,000 a year. So it's a little less than a 2-year payback. OR expansion, right? So we're going to build 2 new operating rooms to reduce the surgical backlog. It's $2.5 million. We're supposed to increase the surgical volume, reduce wait times. We're going to grow revenue over 5 years. It supports patient access and strategic growth goals. So
Which method?
measurements would we use here? Maybe internal rate of return, right? Or ROI. Or excuse me, that internal rate of return or a net present value, right? Is it a positive net present value? Like where are these cases coming from? What kind of cases are they? You may be able to increase OR, volume, but like, are they cases where you get enough margin to make it worth expanding? And then lastly, this LED retrofit, right? So, that's what do we think of this one, right? It's gonna cost us $60,000. We'll have annual energy savings. What is this one? What do we think we do here? Give you a hint. It's one we haven't talked about yet. So total cost of ownership or cost benefit analysis, right? So what's the total cost of ownership for these? So any questions about any of that stuff? All right. Well, let's talk about facility assessments, and Jeff's going to take it away.
Yep. All right. Facility condition assessments. There are, I know they're just a thorough evaluation of the building and everything in the systems and everything that's in it, just to see how they're working, so that you can determine what might need replacing, which would be your capital cost, or determining maybe how you need to budget for your operating expenses for maintenance. In the long run, they help build multi-year capital plans to help prioritize the projects in line with the real budgets that's available. They help with extending the life of the facilities. If you can stay on top of things instead of letting them, I think about houses or something. If you've got a roof that needs to be replaced and you just keep letting it go, of course, letting that leaky roof go is going to damage other things. And I think about it, as you drive by, I see an old house sitting on the side of the road that's totally run down. I'm like, why did somebody just let it get to that? Why did they just stop extending it? Because it could have lasted forever. But the facility condition assessments also can help reduce operating costs by showing where systems are underperforming. So you can find things where they're maybe not efficient. Just determine where you might want to invest your money at. If you could get something that was way more efficient, might save you on your utilities. So that's what they do. And let's see, there's some of the common ways of doing it. There's two methods that are typically used. I mean, there's others, but the two of the more common ones are visual inspections or non-destructive testing. But the visual inspections are just done with just a walkthrough with somebody who's trained professional in this to identify issues and overall conditions. And I know just last week I was in Charlotte in a meeting in the office. We had a firm that came in out of Raleigh that was HIP Design and Consulting. And from what I gathered from their presentation, they consider themselves as that this is one of their niches, is this engineering firm is to do facility condition assessments and performing these visual inspections. Another way you can do it is non-destructive testing, which is it just evaluates the systems and stuff while you keep them running, so you don't have disruptions. They a lot of times can determine things like hidden leaks, overheating, structural weaknesses, and so forth, and identify these things before they become major issues. Some of the ways that it can be done, some of the more common non-destructive testing methods are ultrasonic testing. This just uses high frequency sound waves that travel. And I'm gonna be honest with you, I Googled these because I didn't understand them all myself, learned a little bit from it, but they use high frequency sound waves that travel through material and reflect back. They identify internal flaws and measure thickness. These are commonly used to detect cracks or thinning in pipes, tank, structural components. The infrared technology, it uses thermal imaging to detect temperature differences in equipment. By viewing heat patterns, you can identify problems that may not be visible to the eye. It's commonly used to find issues like electrical hotspots, overloaded circuits, insulation gaps, or maybe HVAC performance problems. Then radiographic testing uses X-rays or gamma rays to examine the internal condition of the materials and equipment. It's commonly used to detect cracks, voids, corrosion, weld defects in pipes, structural elements. Matt, that's what we've had to use, like when we do anything in the Forsyth North Tower. I think they had to do X-rays in the floor and stuff.
Yeah, because that is a
Post-tension.
post-tension, that's a post-tension concrete building. So it's
Yes.
got cables running through the floors that are necessary to from a structural standpoint, right? So anytime you got to do a core drill on that floor, you got to make sure you don't get one of those cables.
Yes, and I have been involved in those where we've done a core drill and all of a sudden they've without X-ray, a cable has been hit, nicked, and it obviously you start worrying about how much it's compromised the integrity of it. So, and if you don't do it up front, you're gonna have to get an engineer involved in the back to kind of figure out and address the issue, the structural engineer. Um, then you got your magnetic particle testing. It's just used to find surface cracks in ferromagnetic materials like steel. And then liquid penetrant testing is used to detect surface cracks or defects in materials. It's got a special liquid dye that's applied to the surface. When it seeps in any small opening or flaws after the excess dye is removed, it makes the defects visible. And then other common detection methods are using your input from staff. So they staff end users, they can usually provide you some valuable insight because they've seen it and they understand how it's been challenging to operate, or they've seen the performance issues that just may not come from a visual inspection. Matt was talking about earlier, maintenance and work order data. That's a big one. So you can review past repairs and reoccurring issues to help just see trends, things that's happened over time, and maybe determine something needs to be addressed and replaced. And then performance and utility data. Think about every time Duke Power sends me that bill and they tell me how my house is performing compared to others in the area that's based on the same age and stuff. You can determine the energy usage will help you determine how well you're doing. So that would be another data collection method.
All right. So we've done our condition assessment, and now we got to figure out how to prioritize it, right? So, we know the condition of the systems, and there's risk associated with different systems failing depending on the areas they serve or what they do, right? So, if you had a single generator in a building with a single transfer switch, that served the entire building, right? That's a very high risk situation, right? If you have like Matthews Medical Center, a lot of our medical centers have single air handlers serving operating rooms, high risk, as compared to, you have 3 generators with multiple transfer switches with you can run the whole building load on on 2 of those generators. Your risk of having a generator failure becomes lower, right? So as you're looking at your systems and understanding the condition they're in, you got to then layer in, okay, what is the risk associated with failure, and what are we going to do about it? How quickly can we mitigate it? How quickly can we get a temporary solution in place to continue operations? How critical is it to maintaining operations, right? So like I often think one thing that, you know, in the healthcare industry in general that kind of gets overlooked from that perspective is assuming we have power, probably the next most important thing is medical air compressor, right? Ventilator don't work without medical air compressor. You know, so that's why those medical air compressors are usually a minimum duplex, triplex, you know, quadplex them, you know, some of them, right? So we need medical air, right? So, you know, the risk associated with that medical air compressor failing is pretty significant. You know, there's just a lot of components we need to think about once we've identified what that risk is. And it really comes down to identifying what's that matrix, right? What's the most important pieces? You know, again, like cooling, right? So, if your chiller fails in July and it's a single chiller, you're going to have to evacuate the building at some point, right? You can't stay in it. So, you know, you can have all the power in the world, but now your chiller becomes your problem. So how do you identify what those risks are based on your systems once you understand the condition? So facility condition index is another just measurement, and facility condition index is a ratio of the cost of needed repairs divided by the value of the building. It's actually the reverse. It's the value. So you want your facility condition index to be low. So the lower the repairs you have, the better your building is, right? The higher it is, the more likely you are. So you want to have that lower FCI just because you know how important it is to have the building operate properly. So, you know, when you're calculating, you know, your facility condition index, you really need to know, you know, how much it's going to cost to replace that equipment, which is going to take into account what maintenance backlog you have, what the age is, what the condition is. You know, do you need to replace it? So you really, facility condition index is simply a measurement of what is the deferred maintenance divided by the building's value. And then you're gonna the smaller that, the less deferred maintenance you have, the better you're gonna be. So here's a calculation. So we know we have $100,000 of deferred maintenance projects. We know we got $50,000 of current projects, and the replacement cost is $1 million. So, you know, the 150 thousand divided by 1 million gets you to, you know, the 0.15. Once you get those $50,000 of current replacement projects done, right, you're going to get a better FCI. You're going to become 100,000 divided by 1 million, right? So you're going to go to a 0.1. So the lower that deferred number gets, the better you're going to be. All right, so you guys have been around, right? So, and you've seen projects like, you know, when somebody's doing a facility condition assessment, what are some of the challenges you might run into? Or even like as you've been looking at a piece of equipment, right? What are some of the challenges in really assessing that piece of equipment?
Finding the time to
Go
do
ahead.
it. I'm sorry.
What's that?
Finding the time to do it.
Yep. Time is a
Not
huge,
affecting operations.
absolutely, right? Time is a huge factor. Alec?
The cost could start off small, but at the end of the FCA, it could lead to a very much higher cost with all the findings that you could locate and everything that you're going to have to repair. And the specialized testing, I feel like that could be a major thing, like the ultrasonic testing. I think that could be a thing that you would have to figure out, and you would have to find someone to actually that can do that, and you would have to get them on site in certain areas.
So is it better to know you have a lot of deferred maintenance than to just ignore it?
Yeah, I definitely think it's better to know, but
Yeah. Well, again, I mean, and then when you know, then you can at least plan around what you know. If you just
Yeah, for
ignore
sure.
it, then you're constantly just responding to whatever happens next. So,
Yeah, that's definitely true.
so a couple of you had jumped in, Will or Jeff,
Yeah.
anything? Okay.
Well, no, I was gonna add, I think access is a challenge. So like with our recent air handler replacement where we were combining two into one, I mean, I think it's fairly common for assumptions to be made for like terminal boxes. You're looking at a representative sample, but not checking every single one to make sure they're compatible for controls changeouts and stuff like that. So those baseline assumptions made by looking at one box can sometimes rear its head on the back end.
No, that's a great point. You know, people look at one or a sample of equipment and not get a good sense of what it really looks like.
Yeah, and
Joe? Oh, go ahead.
in that
Sorry, Will.
well, I was just gonna say in that same vein, access is a problem. So
Yeah.
some of the portions of what you're going to be changing out would be extremely invasive during operating hours to get in and inspect and verify that it's in the state that the record drawings suggested or the mechanical drawings suggested.
Completely agree, right? Our ability to get into certain spaces is very limited. Like, you know, it's nearly impossible to get above a ceiling in an ER, right? Ever, right? And there's always something going on in those spaces, right? You know, you have very limited time to get above the ceiling of an operating room. And when you do, then you got to terminally clean and plan for all that. And what do you do if there's an emergency case? And that's the room we use in emergencies. And, you know, we back ourselves into a corner lots of times with those concepts. So. Joe, did you have something you're going to add? Yeah, Josh, great points on the access and the documentation, right? I mean, I've been working in this industry for a while. I still don't understand why anybody creates as-built drawings because I've yet to find a set of them that are actually accurate, right? Like how many you gotta like redraw the as-built after you get them. And you know, the contractor's supposed to have, or the architect or engineer is supposed to have, you know, modified them based on actuals, and it doesn't work often. So great points. All right, any other questions? Comments there? All right, so let's talk a little bit about just prioritization. We've kind of talked about this on and off as we've gone, and I think I turn it back over to Jeff for this. So.
Yeah. So, project prioritization is something that you just got to do to figure out which projects you want to tackle first. Just figure out which ones bring you the most value, or either which ones have the most urgent need. But there's always projects that are competing for capital. I mean, there's never unlimited funding. So when that's occurring, you gotta figure out how to weigh them out. But there's a lot of things that are competing for it. Is not just there's things that plant engineering has like infrastructure, but there's also technology with IT, medical equipment upgrades. All these are a lot of times compete for the same bucket of capital money that's available. If there's a certain amount each market can spend or whatever, but because every project cannot be funded at once, you have to use a prioritization process to figure out which one has the most critical needs and which ones may need to be funded to keep things running smoothly. It can be tricky though, because there are so many factors at play. Like times it's about competing interest or, obviously the limited resources, and also just the fact that the healthcare environment's forever changing. So you might have, I think about years ago, I worked in IT, and I think about how much the evolution of software and technology. I mean, you couldn't stay up to speed. So you might be planning and investing right now and competing for something, and before you can get your assessment done and figure out they've done changed to a different, new software, new upgrade, so. I think that's pretty much all I got on that one. So Matt, I think this one turns back over to you.
Yeah, give me 1 second.
Okay. You need me to,
No, I'm good. Just give me 1 second.
okay.
All right. So sorry, guys, but just so some factors around infrastructure project prioritization. So, the risk is, what's going to happen if we do nothing, right? Or if this fails, right? What's the risk? What's the impact? So, is it a small impact or is it a big impact? Does it impact all of the building, half the building, or is it just one particular area? What's the cost, right? Like, what's the initial cost to do this? What's the urgency? How quickly do we need to get this done? And then what funding is available to make it happen? So, there's a lot of risk dimensions, right? So there's the technical risks, like what happens if this piece of equipment fails? What happens if the pump fails, the chill water line serving it fails? What are those? What's the operational risk, right? So, we have to cancel appointments. We have to adjust staffing schedules. We'd have to change, the ability to do materials management. Where does the supplies go? Like what supplies are needed if a space is closed? Then the clinical risk, the negative outcomes, right? If something fails, power goes out in the OR during surgery, air handler goes down, in a ICU, medical air pump goes down. What do those all look like? And then, mission risk. How does it look in the public's eyes if we had a failure? What's the reputation look like, and how does that damage the image or the brand? So, how can project prioritization be used to make decisions about capital projects when you have more projects than you have money to spend?
I would say the more critical projects would have to take priority.
Mm-hmm. Yep. Joe?
Well, I guess the ones with the better rate of return.
Yeah.
Mhm.
Right. What other things do we have to take into account, right? Critical, high rate of return, like we talked about earlier, if we have that run to fail situation, right? A piece of equipment just failed. Like it's going to have to go to the top of the list if it impacts our operations in any way.
Mhm.
I mean, I think,
Any other thoughts about this?
well, availability, parts is a big one, right? I mean, even though something costs a lot to maintain, if it's still available that you can spend that money operationally and still maintain it, that's fine. But if you have a piece of equipment that, has been modernized in terms of the mechanics of it and you can't get parts, and then when you have no break fix capability, I think that's a high priority item to replace.
Gotcha. Okay.
I think you gotta think back too, is what we talked about before, that cost if you don't do it. Just thinking about that risk of failure. What happens if we don't act?
Mm-hmm.
No.
All right. So what's the importance of planning for capital renewal? Why I think it's important. So what if we never plan for capital renewal? Al, go ahead.
Would that not damage us with how inflation works and whatnot? And we would need more and more money with how big our company, how big the organization is, and how much everything just keeps on increasing in price.
Yeah, the longer you wait, the more it's going to cost, right?
Mhm.
Probably the more risk you're taking as well, right? So, Joe?
I would say it is gonna hurt your long-term um marketplace value.
Mm-hmm.
You know, your competitors, if they're upgrading and capital planning and you're not, then you're gonna lose market share.
Yeah. John?
I would say significant downtime. If you're not
Exactly.
planning, I mean, you can assess a piece of equipment. You should know about what the life is on it. You know, if you're already having troubles and you see the problem coming in 2 years and you're not
Yeah,
doing anything about it today.
absolutely. Right. And then Josh, spacing those expenses out over time, right? You try to get in a cadence of how you replace equipment so that you don't have a huge amount of stuff that you have to do at one time. So, all right. All right, so some of the elements of the capital renewal plan, obviously inventory. If you don't know what you have, you can't have a plan to fix it. That's why we get so, that's why inventory is such an important part of our work. That condition assessment, the renewal, right? Like repairs and replacements to keep things in good working order. What's the priority? That ranking of renewals based on risk and impact. Budget, how much does each repair cost versus what it's going to cost to replace? I mean, we've run into this before where like, you might have to replace a motor or a condenser or something on a chiller and, it's a 30-year-old machine and it's $100,000 repair and, it's $150,000 for a new machine, right? So sometimes it's better to just make that investment. And then timeline, what's the schedule that looks like for all those tasks? So kind of the what I call about is the four dimensions of error, right? So, if you replace it too early, you're wasting money. If you replace it too late, it's already failed, like you didn't do it proactively. Um, underfunding, right? You're just you again the same as waiting too long, right? Systems fail, you have delays, etc. And then when there's too much money, you're taking that money and so two things on too much money. One is you're taking it from other priorities of the company, but you're also um uh you're taking it from other areas of the company, but you probably can't get it all done, right? There's only so much work you can do in a period of time in an operating facility. So you could take, like, somebody could say to me, hey, you guys get $100 million this year. There's no way we could spend it this year. There's just you can't do that much work in operating facilities, so you gotta follow that double-edged sword a little bit. So deferred maintenance and capital renewal again, reduced capital investment results in deferred maintenance, which makes the facility deteriorate. As maintenance backlogs grow, condition declines. Once you get a particular point of deterioration, you just have to get to a full replacement, right? You can't maintain it. And then those consequences of not addressing it are unexpected cost, operational disruption, safety risk, etc. So just a couple graphical, you know, examples, right? So as here, your capital and maintenance investments are, you see the required sustainment level gets lower, your capital investments lower, so you're accumulating your deferred maintenance. Here, the next one, you kind of have a deferred maintenance balance where, you've got new deferred maintenance. You can see there, and then as you don't spend money, your facility condition index score goes up. Remember, we want that score to be low, so the less money you spend, it goes up. Pop to the next one. So sustainment percentage is a metric to look at the average percentage of current replacement value necessary to sustain an asset's current condition within a 10-year planning window. And that's the maintenance and repair costs divided by the replacement value. So if that sustainment percentage is around 2%, then 2% of that cost is what you're putting into that equipment to keep it up and running. The benefits of it kind of helps you develop a capital budget. You understand that, once you start spending more than, 25, 30% of the value of the equipment every year on keeping it running, like, we really got to start to evaluate what's important. Helps us prioritize and track those replacements and then benchmark performance of the program. This is just an example of that 2% calculation. So we got a $200,000 of maintenance for an imaging suite. Replacement value is $10 million. So that's 2%. So we need to put 2% in every year to maintain that equipment. So funding, which is probably the most important part. We talked about this a little bit earlier with kind of the buckets of money we have, right? So, we take a percentage of our, earnings every year and put back into capital. And we fund them through, typically we fund all of our projects like infrastructure type projects through operating revenue. Big new construction projects will debt finance, and that's the bond sale after a project's complete. And then we'll do, there's some grants and then, the philanthropy, right? So, I know the Jordan family's donated, Michael Jordan's done a couple of clinics. Jordan family just made a big donation. The Belk family just donated money over the years for heart projects, the Wesingers for cancer. So there's, a fair amount of philanthropy that comes into play at times as well.
All right. So, sometimes, and we've seen this at different times through my career here, but there's times that we're doing better than others, and sometimes we have to get a little creative with the financing options just when we have limited capital resources available. There's a list here of several popular options that some organizations use, but the three at the bottom are ones that I personally have seen, and I don't know if the ones above are used. Like, I don't know, do we ever do lease to own, Matt?
We have done it we've done it occasionally on like equipment, but very rarely. We don't really do it on facilities.
But the three there at the bottom, the tax exempt bonds, I mean, I know we bond finance. There's been new hospitals, there's been things like that. It's been bond financed, and man, it gets tricky at the end trying to keep up with all this, and it ties directly back to your depreciation and stuff. And I know, and I've heard Melinda Gallup say, well, no, that's bond financed. And so, I mean, even if you want to sell the asset or something, it gets real tricky if you've done it through bonds. But then the developer models, we do this a lot in medical office buildings. A lot of times we have, instead of spending all of our money on, we'll have a developer do do all the site work, build the shell building, sometimes even do the interior upfits, and we just basically move in. I mean, they lean on our design standards to design it and so forth, but more often than not, they construct do the site and shell, and then we come in and do an interior upfit. We just take care of the interior portion rather than invest in all of it. And then the other option we've had are tenant improvement dollars. A lot of times, a landlord will offer us tenant improvement dollars to help fund part of our upfit and so forth. But basically what happens is that means your lease rate per month is probably going to be more. They're going to get that money one way or the other. So they'll chip in some funds to build it out, but they negotiate that how much it is. And let's just say going to give you $20 per square foot. that's less that we have to ask for in capital, but more that we'll pay for in operating expenses over the term of the lease. Tanya might have something good to add to that. She's involved in negotiating those.
Everybody's asking for tenant improvement funds these days or turnkey.
Yeah.
All right. So, energy infrastructure renewal, we've talked about this some. You guys are aware of the Enfra. I know John's working on it. So this was a unique way we used to, to raise funds. So in the Enfra model, essentially what happens is, there's a couple the starting point of it is, and you can replace Enfra with there's some other energy as a service companies, but they come in and they assess your plant's steam and chill water capacity. So if you have excess chilled water for steam or excess capacity for steam and chilled water, that checks a box. And then if there are legitimate available third-party off-takers who you could sell that steam and chill water to, so like a medical office building, other components on the campus that you could sell that to, that checks another box. So that excess capacity has value. If you have excess capacity that you could sell to somebody else, that has value. So in our energy as a service transaction, 9 of our 19 campuses checked the 2 boxes. Then what Enfra did was they figured out what the net present value of those of that excess capacity is over the next 30 years. The value of that excess capacity over the next 30 years is $855 million. So then Novant gets $855 million today. And the way they get that today is Enfra sells bonds to pay for that, because people will invest in that. So they sell the bonds, they give us our money, and then we pay them back for that money over time, right? Through energy as a service, right? So it's essentially, and then in order to get, as we were talking about earlier with rating agencies, right, and accounting treatment, in order to get those 2 things to work correctly so that this doesn't become debt, you reinvest in your own buildings, right? So we're doing $170 million of energy savings projects that have a guaranteed savings with them, and then $200 million of infrastructure. So of the 855 million, 370 is being, over the next 4 years, will be invested in our facilities in both infrastructure and energy savings projects, and the balance the company could use for a variety of tasks. So, really, when you think about it, it's just a unique financing mechanism. In a lot of ways, it's called energy as a service because some organizations will just do a small project and the actual energy savings will pay the debt back. But in our case, we decided to take more. So we're paying that back over 30 years as well, but we also get the guaranteed energy savings, which is, year 5, which the first year everything's installed, is about $6 million a year. So, it's real dollars, but it's just an alternative financing mechanism to find, other ways to pay for the work we want to do.
Okay. If you don't mind, you can probably close the slideshow down. I'm going to share my screen because I'm going to show you some of these forms, some templates, and a few things here. And I've got it pulled up on my other screen. So to begin with, I pulled this up earlier when I was talking to you guys about contingency. The contingency list. But this is a copy of, this is a form. We have a tool that we use in design and construction. I think plant engineering uses it some as well, especially for infrastructure projects. But we have a tool called Projecto that's used to manage projects. And John, I know you were just recently on training for Projecto, but prior to, even with Projecto, we used to not use the budgeting tool as much as we thought, not like we should. So we used everybody had their own versions of an Excel form that was used to put budgets together for design and construction projects. finance asked us, because they got so many different versions, if we could consolidate down to one version. So we did. And this is the version that we consolidated down to. I kind of keep it updated and keep it on our OneDrive so all the PMs have access to it, even though I think it gets used less and less now that we have Projecto. But it pretty much calculates everything that we've seen, or considers everything that we've seen in our construction projects in the past. So from anything you get into here, we are into our site work, and then we got our base cost and any alternates, permits, demolition, pneumatic tube systems in hospitals. If we need to consider abatement for building a new hospital, we got to get third-party med gas verifications done to get our DHSR approval. Anyway, you can see all these different things that it covers. Then we get down into our low voltage systems that are part of a new build. We have to put our nurse call in. Intrusion systems, not so much, it'd be more in a clinic, but we got to always have access control with badge readers and cameras. I mean, even if that means to get in and out of an OR, an IT closet, so forth. Fire alarm systems typically included in the GC scope of work, but sometimes in off campus, we have to budget for it as a separate line item. And then our building automation system, a lot of times in our MOBs. And then within this file, I can change my contingency calculation, and it does it for you. For instance, if I have a $100,000 there, I got 10%, it automatically calculates $10,000. If I want to change this to 5%, it changes to 5. So if any of y'all are interested in a copy of this for maybe something you're budgeting for, I'll be glad to share the latest copy with you. Then we have our architect, all the architect and engineering fees. Sometimes these are included in a planning capital request. Some of this is things that you need to do just on the front side, just to figure out, get a design to a point that you can actually put a budget to the project. So we have our architect and engineering fees, and sometimes these are broken out. I've got it lumped together here, or it can be broken out. These are all phases of that fee, from the initial planning and programming through the schematic design, design development, through construction drawings that are issued for permits, bidding and negotiating, and then the construction administration while it's being handled. If we hire a GC during the design to help us keep the budget in check, we have a pre-construction fee from them, our permit review fee from the local AHJ or county or whatever, get a fee. Physicist reports, if you're doing imaging projects, you need to figure out what shielding you got to put into this, what the walls, how much shielding you need, what it's got to look like, so that your contractor, you can get it during design and they can pick it up in the cost of construction. We have DHSR review fees, certificate of needs, and then we have commissioning, which I know would be really important to a lot of you guys, especially being plant engineering. We want to make sure that these systems work properly together. So that commissioning, we try to budget for it. And according to a previous, a lot of these, we've kept up with, we usually budget 0.3% of the cost of construction for commissioning. And y'all, I may be getting too deep into this, but it won't take me much longer. But then we have our equipment. There's very little that fixed assets calls fixed. They say it's fixed if you can turn the building upside down and it stays in place. It's movable if you turn it upside down and it falls out. But things like signage, it still stays attached to the building even if you turn it upside down. Blinds and things like that, we would leave with the part of that. And in our food service equipment, is typically these are big things, but we have to consider these in new greenfield hospitals. They're not, in every project, but if you're building a new hospital, it's got a new cafeteria, you got to calculate that in. So again, trying to capture everything that we could possibly think of. Then you get down into your movable equipment, all the medical equipment, artwork. These are food, just tools like even down to the point of lockers and a safe and digital menu boards. Sometimes in a clinic, that would be your break room appliances. They're not tied to a cafeteria, but you still need to plan for, in a break room, to have a refrigerator and a microwave for your staff, to have chairs and stuff so they have a place to sit down and eat their lunch. And then sometimes curtains and track, most time provided by GCs, and then just general furniture. That's your lobbies, your waiting rooms, your so forth. And then we got the IT cost. IT typically involves, I mean, you obviously have your computer equipment and hardware, and that can be anything from UPSs in the closet to the routers to the switches. All that's hardware down to a desktop PC, or you get it down into software. You got some places, like if you're doing a cardiology clinic, they have specialty software for their transferring of their images and so forth. Electrical here is typically all the low voltage cabling involved. Like, I know you guys probably seen A-Excellent in, they do most of that cabling for us, but it's voice, data, nurse call, but it's typically built into the IT budget. And sometimes there's contract labor, things that they may use an outside vendor to do. Could be from hiring outside vendors to do the actual place the equipment and install. Same type deal. I can calculate, change my percentages. Then at the bottom line of it, we have to calculate what's called capitalized labor. And this is actually a Novant policy on design and construction projects. And cap labor is actually, it's something they get to, as if they were going to, it's a project management rate as if they were going to outsource someone to manage the project. So it kind of helps justify, Matt, if I'm explaining this wrong, you help me out, but I think it kind of helps justify our salaries and stuff within design and construction or project managers.
Well, sure. If we didn't have internal project managers, we'd have to use third-party project managers. So it counts against their salary. Yeah.
They count against our salary, but they also use this, I think, in their depreciation process. They get to, calculate this into that, that it wasn't all a, so anyway, rates depend on how much the project is, but it's per a policy. Other little things we have to calculate: insurance. We have to calculate builder's risk insurance to our projects. We calculate OSIP sometimes, which is an owner-controlled insurance program, totally different than builder's risk. That's where we carry instead of the general contractor carrying it. And then here's where we can add, if we need some kind of additional contingency, if we just say, okay, I want to put an extra $500,000 on here, it adds it up. And then a lot of times you save this sheet, typically as a PDF. And then I'm going to show you a couple of other things. And this is kind of where it's going to lead from one step to another. So the next step after you've built that budget is to prepare the capital budget form that is submitted to finance. So to find that form from our Novant homepage, internet, if you go under corporate departments and you go under finance, and then we go to capital forms. Capital forms, there's two different ones here you would use. So there's a planning capital. That's an update, I'm sorry. Planning capital budget request. So this is used just to get enough dollars to plan this thing out, to figure out, so you can get far enough along in design that then you can submit a true capital request. So this one is then used for capital projects to get entered into the Strategize. And then you got to provide this requisitioner with, they got all the supporting documentation. So the capital budget request form, once you click on it here, you got to download it. They got to enter. Most of the time we help them fill out this section to make sure we get the money broke out into the right buckets, whether it's into buildings, if we own it, leasehold improvements, if we lease it, Then you get down into your major mobile equipment, your computer equipment. This has to get broken out right so that as your project managers are coding invoices, issuing purchase orders, and so forth during the whole project, that they draw from the right place, take their money from the right bucket of money. End users typically fill out all this up here. This is their department name. They're the requester. That's their contact number. And then they need to provide the justification and all that. This is their project, not ours. We're just assisting them with it. But that shows you the form. And then after you get the form and they submit it to finance and it gets entered into Strata, when it goes through Strata, I'm going to pull up in a project that I'm actually working on as an example. This is a project that I'm working on, just finished. They just opened last week, I think it was. And within this project, first of all, when you start asking for capital approval, there is a routing slip which shows all the different people that this thing has to go through to get approved. So it starts off and it's gone through all these different people. And, you'll see on here, there's people like in this one, Mike DeCatano was involved in reviewing, and then here's an IT person involved. Get on down and it gets into executive levels, and you get down, and I don't know if I can see who some of these are. Kim Griffin, she's a finance person. Anyway, there's Naveen, I don't know how you say that last name. I know who he is, Bajwani. Anyway, you can see a lot of things, a lot of different people who all has to go through for reviewing. Here's when it once it actually gets down to Melinda Gallup's team and right before they assign a can. So that's part of the thing you can see. And I was talking about, it said that you had to have these attachments with it. So anything that's presented, they need to have a pro forma, which is their business plan to show how you expect this project to perform. How's it going to make money, or what makes it valuable to the organization? So that kind of gets back, and they can use this in their prioritization. So even though we talked about some of those ways, those net present values and all that, I help a lot with putting the budgets together. I don't, but the way they weigh it is done by others. So I'm not as familiar with those processes, but in this particular case, I did help prepare the capital budget request. And I'll open this file. Well, this was her request, 1.6 million, or right at it. It came from doing one of these. And let's see what else she had. She presented this to the capital. Here's her pro forma, an example of it. But the end users do this, but they start figuring out how many years it's going to take. And I can't tell you that I fully understand all this, but they kind of tell you what it's going to take for them to break even and all that. And people in finance understand this more than we do to figure out whether this project's worth doing or not. So you can see she talks about the 5-year net present value and the rate of return, 5 years, and so forth. So it looks like, in my opinion, this one's going to take at least 5 years to break even if I'm looking at it right, because that rate of return is 0. Anyway, I think that covers most of the forms that doing, but I would just highly recommend that if you're going to submit a capital request, go in and download that latest form. Because sometimes finance makes revisions to it. So go into that corporate department's finance and download a copy of the latest form before you submit it. Instead of like saving an old copy on your PC and keep going back to it, because it does change from time to time. And that's pretty much all I've got to share, unless you've got any questions for me.
All right, guys. So we're kind of hit the end. Any questions and answers, or you could give me answers too, but any questions? We went through a lot of materials this morning. So any questions on any of it? Well, I hope it was worthwhile. I appreciated the really good discussion. I think we had a lot of good discussion today. It can be hard sometimes in these virtual classes to get that level of engagement. So I appreciate you guys hanging with us and participating as much as you did. So for your homework, just going to conduct a mini condition assessment. So, you can mechanical room, electrical room. And so just pick a, equipment room at a facility and conduct a condition assessment. What are the physical assets, any environmental conditions, and just talk about what you found, what the severity is, prioritize your issues, and then develop a brief plan about how you would prioritize what needs to be replaced. And then just a quick idea on funding mechanisms and what maybe creative financing options there are, like we talked about, and then submit it in the learning management system. So guys, don't overthink this. You don't need to be an expert in everything. Like, John said it earlier, you guys can all go look at a piece of equipment and give a general assessment of the condition it's in. So you don't overthink it. This doesn't have to be detailed down to the, controls level, that sort of thing, but just you make sure, and like, if you do mechanical room, right, do the air handler, do the panel. There's a heat exchanger, do the heat exchanger, whatever it is. So just any questions about any of that? Great. With that, any final questions, comments, concerns? Again, I think from Jeff and I's perspective, appreciate you guys being real interactive, and I know this, times this can be, some of this financial stuff's not as exciting, but just seeing how the financial work ties into the real facility work is important, and we'll just keep on keeping on. So I hope you guys have a great rest of your day, and let us know if we can do anything to help you.
Yep.
Thank you.
Thank you guys very much.
Thanks, Matt and
Have a
Jeff.
great day.
Thank y'all.